Assalamualaikum and good day. I'm Siti Nur Muhammad Rum from the Faculty of Computer Science and Information Technology, University Putra Malaysia, and I would like to present a research work entitled Public Transport Delay Prediction Using Deep Learning. This is the outline of my presentation. The quality and availability of public transport services in a country can greatly affect citizens' lives as they may rely on them for transit to work, school and other areas. Having a good and efficient public transport system is important for facilitating better travel and reducing road congestion. However, public transport services commonly have several issues, including long waiting times and long travel times due to delays. Public transport delays can be caused by several issues such as the traffic congestion and bad weather conditions. Therefore, predicting public transport delays with precision is a crucial element of an intelligent public transport system. The combination of several non-linear components such as traffic condition, dwell periods, incident, etc. may affect public transport arrival timings. Typically, it is challenging to represent this interaction using traditional modeling tools. The availability of more accurate estimation of public transportation delays can increase user confidence and their willingness to pay for transit services. Therefore, there is the need for algorithms to improve prediction accuracy due to the complex nature of the urban environment and the various factors including bus arrival times. With the machine learning algorithm, better results and robustness can be achieved. However, extrapolating a large dataset in short time periods to produce precise forecasts is challenging. Over the past 2 decades, a number of studies on prediction algorithms for transportation data have been proposed, and most of them were focused on the transportation and traffic flow analytics. Recently, there have been even more studies on developing prediction models for public transportation delays. The studies have also used a wide variety of models such as the Bayesian networks, decision trees, deep learning, common filters, multivariate regression, and random forests. However, many of these recent studies have only used public transit data for their model, so many other factors such as road and weather conditions could have an impact on public transportation. By including other external data into the transit prediction models can provide more holistic model. Table in the slide shows a summary of recent works on the transportation delay prediction. To realize this research work, the study was conducted using a PC running on a Windows 10 operating system with the Intel Core i5, NVIDIA GeForce GTX 10606GB GPU, and the code was programmed using Keras, TensorFlow, sklearn, and Pandas libraries using Python programming language through Jupyter's Notebook. The datasets used for the study are the Toronto Transit Commission's delay dataset from the Open Data Portal of the City of Toronto and weather data from Weather Dashboard for Toronto. Data is selected for a 6-year period time from January 1, 2014 to December 31, 2019. The streetcar delay dataset has 78,525 entries with 10 features describing streetcar delay incidents in Toronto, while weather dataset has 2,191 entries with 70 features describing Toronto's daily weather data. So table in the slides provides a list of attributes of the dataset with the description. So this is the architecture of a deep neural network DNN model that shows layers between the input and output with several hidden layers. So these hidden layers enable DNN to discover intricate patterns in data, making them powerful for reinforcement learning, natural language processing, and image recognition. In this study, the MAE is the metric used to measure the accuracy of a proposed model. So in the context of machine learning, absolute error refers to the magnitude of the difference between the prediction of an observation and the true value of the observation. MAE makes the average of absolute errors for groups of prediction and observation as the measurements of the magnitude of the errors for the entire groups. MAE can also be referred as L1 loss function. Slide present the accuracy of the trained deep neural network model on the test set over the 10 folds measured in MAE. The average MAE over the 10 folds is 3.21 minutes. The slides present MAE results for several models in machine learning together with deep learning models for predicting public transport delay using the TTC datasets. So obviously the result shows that the deep neural network outperform other models with an MAE of 3.21 over 10 folds. So in evaluating machine learning models, including deep learning models, 5-fold or 10-fold cross-validation is commonly used in practice. Today's values strike a balance between the variance reduction and computational cost. The DNN models result also shows a promising improvement over the previous study. So this result could suggest that when predicting the length of delay in the public transportation, the DNN model could be considered as one of the best models. However, there are several things that need to be considered when practicing public transport delays, such as the architectures, hyperparameters, and processing techniques to determine which model performs best. Another process that may have contributed to the best model performance is the feature selection. The rain and the snow features were considered detrimental to the model learning process and excluded from dataset used by the proposed model. To conclude, our finding shows that the DNN model performed better than other models with a mean absolute error 3.21 over 10 folds. However, to ascertain which model performed best, several factors including pre-processing techniques, architecture, and hyperparameters must be considered when predicting public transport delays. Future research could also benefit from looking into other deep learning methods for estimating public transport delays and comparing the results of these models on the various transit datasets. So this is all the references. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Thank you for giving me the opportunity so I can present this research with the title Combination 2D PCA, Two-Dimensional Principal Component Analysis, SPCA, Sparse Principal Component Analysis, and Rate Regression Model for Face Recognition. This research was carried out by myself and with the guidance of my two supervisor, Dr. Eng Adichandra STMcom and Dr. Suyanto MCom. The background of this research are the first one is dimension and redundant. In carrying out face recognition, there can be an increase in the computing process and the time required increases. This is caused by the data or face image having high dimensions and the information contained in the image is irrelevant or redundant. The second is sparsity and relevance. Not all features in face image data are relevant to be used in the recognition process. So a method is needed that can improve the recognition process by only using important features. The third is overfitting. In carrying out the recognition process, overfitting still occurs. The model becomes too complex in recognize the training data, but cannot generalize well to data that has never been seen before or test data. And the last is regularization. In the recognition process, a good regularization technique is needed which can control model complexity and prevent overfitting so that it can generalize well. Problem statement in this research is in the face recognition process using 2D PCA or two-dimensional principal component analysis method, overfitting still occurs, which is generally caused by the data noise, high model complexity, excessive features, and lack of regularization. To avoid to avoid this, it is necessary to carry out a good regularization process and optimize model performance by choosing the right method. The data used is primary data. There are 320 objects. Each object has 12 images. The total number of images in the dataset is 3,840 images. This is an example of a collection of images or the dataset used in this research. And this is example image in the dataset. And then the goals of this research are to assess the capability of the 2D PCA and SPCA in feature extraction and feature selection, and to evaluate the effectiveness of risk regression model regularization technique in avoiding overfitting and enhance the model's generalization ability, enabling efficient face recognition process. And this is the architecture of the system. Start with the input dataset. Then dataset is divided into training, testing, and validation. After that, image preprocessing is carried out, namely resizing. Then feature extraction using 2D PCA, and the most informative feature selection using sparse PCA, and regularization using Ritz regression model. And the last is evaluation using confusion matrix and holdout validation. This research was carried out by taking references from previous research. Some previous research are in 2020 by Sinde et al. With the title is Python-based face recognition for person identification using PCA and 2D PCA technique. In 2020 by Taskiran et al. Face recognition, past, present, and future. This is a review paper. In 2021 by Zhao et al. The title is Advanced Variations of Two-Dimensional Component Analysis for Face Recognition. In 2021 by Kamako et al. All sparse PCA models are wrong, but some are useful. Part 1, computation of scores, residual, and explained variance. And the last is by Kamako et al. In 2021, with the title is All sparse PCA models are wrong, but some are useful. Part 2, limitation and problems of the patient. And the face recognition system built has an interface. Consists of several features or menu. There are dataset to adding dataset, training to performing training process, validation to performing validation process, testing to performing testing process, to the PCA testing process using to the PCA, and the last is testing process using to the PCA, SPCA, and risk regression model. This is a view of the system interface. And this is a view of dataset menu. And then this is a testing process with 2D PCA and testing process with combination methods 2D PCA, sparse PCA, and risk regression model. And in the training process, there are the number of dataset and image, and the processing time is also displayed. And this is the result of system. In this image, we can see feature extraction using 2D PCA. 2D PCA will produce image reconstruction. After that, the results of image reconstruction using SPCA were also obtained. We can see the difference in results between 2D PCA and sparse PCA. This is an image of the difference in feature distribution for 2D PCA and SPCA results from test data. And the difference in feature distribution for 2D PCA, sparse PCA, and ridge regression on PCA results from test data. And this is an example of prediction, test data, and training data with with a mean square error value is 716.40. And this is an example of prediction, test data, and training data with a mean square error value 2515.65. From the result, it's known that the test data has the closest similarity to the first training data with a mean square error value 716.40. And this is a testing process. We can see the difference accuracy between 2D PCA and SPCA. Accuracy with 2D PCA conventional is 96.41%, with the number of true are 617, false are 23. And accuracy with combination tree methods is 99.38%, true are 636, false are 4. And we can say that combination to the PCA, SPCA, and regression model can improve face recognition accuracy. And this is a graphic image of recognition accuracy with 2D PCA. And for axis is dataset 1 to 320. And for y-axis is accuracy. 2D PCA accuracy ranks from 20 to 60%. And this is a graphic image of recognition accuracy with combination method. For x-axis is dataset 1 to 320, and y-axis is accuracy. And accuracy range from 60 to 100%. And this is an evaluation of the system. Accuracy is 99.84%. It means system is able to correctly identify 99.84% of the entire testing dataset. Recall is 99.84. It means the system is able to identify around 99.84% of all true positive data. And precision is 1. It means that all positive predictions generated by system, all of those predictions are correct. And F1 score is 1.98. It means that system has a good balance between precision and recall. The last is conclusion. 2D PCA is capable of performing face feature extraction well, but there are still errors in detecting face and recognized face. Sparse PCA can select the most informative face component features so that the system can detect face well. The ridge regression model can overcome overfitting and high complexity issues, allowing the system to perform face recognition better than using only 2D PCA conventional. And combination of the 2D PCA, sparse PCA, and ridge regression model can overcome the weakness of 2D PCA in detecting and recognize face, resulting in a face recognition accuracy is 99.99%. 38%. And the last but not least, the future work is enhance dataset processing to improve image quality by determining the photo capture angle within a specific range, for example, from 30 degrees to 150 degrees, and increase the dataset size or the dataset number and select a better model evaluation method. Thank you.
Assalamualaikum warahmatullahi taala wabarakatuh, and good day, ladies and gentlemen. My name is Noris binti Muhammad Norawi, and I will be presenting my paper here at the International Symposium on Intelligence and Internet of Things in Perspective from Indonesia and Malaysia. The title of my topic or my study for today is Traditional Malay Music Genre Classification Using Machine Learning. So my uh, co-researcher is also Ahmad Zaki Sharafuddin, and we are from the Faculty of Computer Science and Information Technology, University Putra Malaysia in Serdang, Selangor. So this is the outline of my talk today. It will be including introduction, problem statement, background literature, general mechanism, conceptual framework, experimental sets, results, conclusion, future work, and references. Okay, so as the name suggests, we are working on classifying musical genre, and music genre classification has been one of the interest field in recommending systems. So we have had like image classification, and then we also have now audio classification, and there are many forms of audio that need classifying, and some of them for the purpose of like recommendation system, such as track separation using the Shazam app and also SoundHound. This is where we want to find similar sounding sound, etc. So there has been many progress in audio classification. It's not a relatively new field. It's been around for a while, and it's sort of like peaked around the 2000 something, this audio classification, but there's always recent progress coming in, and also there are areas to always fix this, because it all depends on the data set and on what we are trying to classify. So for this particular study, we are focusing on the traditional Malay music. So this is like folk music, but the folk music for Malay, Melayu music. Okay, so there are 5 different traditional musical genres that we include in this study. These are Dike Barat, Malay Gamelan, Ghazal, Keroncong, and Zapin. So they are quite different, very different from one another. Like Dike Barat is mostly performed in originated in Kelantan. It involves collaborative rhythmic hand clapping and group singing. Normally tells the story. Malay Gamelan is involving an ensemble, and you have various percussive instruments like gong, drum, uh, gambang, bonang, um, uh, and all other things like saron, baron, and all that. So these are all metallophones, and they are arranged together to produce intricate melodies and rhythmic patterns. And then we have ghazal, which is heavily influenced by the Arabic poetry and include instruments such as harmonium and tabla. Keroncong is quite similar to what is also keroncong in Indonesia. It's a cultural fusion, and it has vocal harmony as well as instruments, including more modern or Western ones such as ukulele, and it draws inspiration from the Javanese and Portuguese music. Zapin originated from the state of Johor in Malaysia, and it's involving a kind of dance, but it typically has this rhythmic drumming and some percussive instrument as well. So these are some of the examples from the first one, which is instruments for Dike Barat, for gamelan, Malay gamelan, for keroncong, uh, ghazal, and zapin. And then the motivation behind this study is that different communities listen to different kinds of musics, and it is important that we have specific um, studies on this music. There's no like one solution solves all. So if it works for Western music, we can't really say that we can use the same model to train and classify other genres. And also, the most popular model right now is used for in music classification are blues, classical, country, disco, hip hop, jazz, and these are all more Western genres. So although they have been work on traditional or folk music, we need to increase more so that this area can also be improved and not just on the Western music. And then there's also another motivation is that we still believe that the MIR problem, music information retrieval problem, still have room for improvement. And with the potential of machine learning, we can do much better in terms of achieving higher classification result. Okay, so the problem statements for this research includes to be able to identify which combination of features give the best accuracy for traditional Malay music genre classification. So we have a lot of audio features that we can extract from the audio. However, we need to identify which feature or which combination of feature gives off the most accuracy, in particular for traditional Malay music, which is what we're studying. And then we also have the difficulty in determining the best classifier that can be used. So, of course, we are looking not just at the features that we need to extract, but the best classifier to use in this instant. And then we have the background study for all of this. Uh, so the work has been ongoing from, like I said, the past 20 years or so. So we have the work from Doris Semi and myself, our team, which was in back in 2008, and we studied on some of the features which include STFT, timbre related feature, MFCC, and also a beat feature, because traditional Malay music they heavily rely on rhythm patterns. And then we also have correlation based feature selection with genetic search strategy for the classifier, and we managed to achieve the accuracy result of 88.6%. And then we also have here other people who have been working since then, maybe on 2018, 2019, using different features such as spectrogram, time frequency segments, and then different classifier as well. We see KNN, HMM, neural network support, vector machine, and so on, and with various degrees of success. So around 80% was achieved using some of these examples here. And then there has also been work that tried to focus on using image for classifying the audio files. And this is by focusing on the spectrum or the spectrogram produced by the audio. And these are some of the work, quite recent, 2020. So before this, it was always thought that audio needs to be, because it's an audio file, we need to extract the audio features, but we or the work has expanded to exploring the image um, as well, to see whether we can also classify audio this way. And again, various range of success from maybe 70%, 85%, 96%, which was 97%, which was among the highest at the time that was managed to be achieved. But and then also inclusion of DNN, deep neural network, managed to get quite low here, around 38%. But this is trying to move on to using like deep neural network in the work. Um, Going back to the previous slide, the work is still ongoing. So we are trying to take the same approach and use it not just on Western music, but extend it to traditional Malay music. So this is the conceptual framework. We have two sides, which is on the audio side and on the image side. So on the audio side, these are the features that we extracted chroma features, spectrocentroids, MEL spectrum, and MFCC from the files of audio containing 5,034 dataset, and then the results are then classified using random forest KNN and CNN to see which one is better, and then we perform model training and then model testing to get the accuracy, and we manage to get the result. And same process is done for image, but instead of using the same the same audio features, we tend to use the spectrogram, and we manage to extract the chroma and spectral features from the spectrogram. This is the basic methodology. We have planning, data preparation, including trimming and all the cleanup with the raw audio, and then we do the image processing as well with the spectrogram image, and then afterward we do audio extraction, and of course extraction of from the image process as well, and then we do the model engineering part where we build the model, we train the model using teachable machine, and then we export it to Weka, and then we do model evaluation, and then we do deployment, testing, and then of course monitoring and maintenance when needed. So for our experimental set, audio based, we have several sets, including looking at different features, single features, the 4 features there. And then we looked at combining these features like MFCC and chroma, MFCC and centroid. And then 3 feature combination, MFCC, chroma, and centroid. And 4 features combination, MFCC, chroma, spectral, centroid, and null spectrum, basically including all. And we compare this against 3 classifier, random forest, KNN, and CNN. And for image-based classification, we perform the same, but we only end up with 2 features. One is single features using MFCC and chroma. These are the visual managed to be extracted from the images. And the classifier is the same again. We use random forest, KNN, and CNN. This is just a general result from the audio. It produces this some sort of this is the interface where the audio is produced, and we can see the results here. The results is better presented here, where you can see the different features or combination of features is ran against different classifiers, giving off different results, and then also the time or performance taken to do this, to complete the task, is also recorded. So MFCC, surprisingly, although on its own it seems to be logical that it's once featured at that it should be faster, and but that is not always the case. It produces actually the highest number. It takes the longest to perform, and whereas when we include all features, it does not make that much of a difference compared to single or other combinations. And the result, however, is a bit is unsatisfactory because it is around the range of 20%. This could be resulted, or this could be because the data set that we had was quite small, and it was very difficult to find authentic data sets because of the inavailability of traditional Malay music itself. Is not as vast or as easily accessible as other Western music in order to get the data set. This is the same result, but in a different representation, being represented in a bar graph. And we can see that the best result is the using all 4 audio features, but extracted using classified using KNN classifier. So we continued using images to see if we can possibly get a better result with maybe lesser resources or lesser effort. So we compare MFCC with chroma features, and the result is that we managed to increase the accuracy result into the range of 62% using chroma features, which is the features extracted from the spectrogram. And it was also 60% for MFCC. So the result has increased, or has become better when we use image based classification for audio files. So to wrap everything up, there are different features, and different combination of features produces different result. But for this particular study, the best feature is by using the combination of four features, which are MFCC chroma feature, spectrocentroid, and magnal spectrum for audio. And in addition, if we use image-based classification, we can achieve higher accuracy for this particular data set, up to the range of 62%. And if we use KNN algorithm. So in general, we would like to conclude that there are still many areas to explore with this particular feel, but we need to do it at least one step at a time. And to this is one small step in preserving the heritage and traditional music that we have. So hopefully in the future we tend to continue with the study and explore many other possibilities of feature combination. And what is most important is trying to get a larger data set so that we can have better representation of the genres. And of course, if we can, we would like to include other genres, traditional Malay musical genres as well, in addition to the five that we already have, because we have so many more, such as tumbuk kalang, um, maybe the ethnic Sabah sounds, and then we have also um, uh, potentially so many more genres that we can include for future work. So thank you very much. These are my references. I'm Noris Muhammad Narawi, and I hope I have been able to share some insights with you on this particular project. Thank you very much.
Okay. Assalamualaikum warahmatullahi wabarakatuh, and very good day to everyone. My name is Dr. Nur Azura binti Hussein, and other authors for this project is Huan Zhangji and also Dr. Raihani. Okay, so today I would like to present my project entitled Exploring Edge Device-Based Lightweight Deep Learning Model for Face Recognition. Okay, so this is the outline for my presentation. First, we go into the introduction and then research problem, and then we have objectives, the scope of project, literature review, dataset and preprocessing, results and discussion, and the last one is about the conclusion. Okay, as an introduction, the edge computing, which involve the processing data locally and reducing dependence on the cloud-based system, offering several distinct advantages for time-sensitive application like a facial recognition. However, it does present some challenges, particularly in terms of limited computational resources compared to centralized computer-based system. Okay, significant progress has been made in the field of object detection with the YOLO series, which is renowned for its efficiency and accuracy. Okay, YOLO 8, the most recent iteration in this series, stand out from its predecessors due to the increased effectiveness with which is perform object detection tasks. Okay, so based on this research, okay, we come up with the two problems. First is about the computational load and model size. So the goal is to optimize the YOLO 8 for each device by reducing computational load and model size, considering their limited resources. Okay, so this involves the architecture changes to YOLO 8 to ensure the efficiency developments and operation. And then the second one is in terms of the real-time processing and also the different environment and maintaining precision. So the impact of these changes of on YOLO 8 facial recognition performance is to study by considering this that real-time processing, the adaptability to different environments, and to maintaining the precision. Okay, so the primary goal is to transform the YOLO 8 into the paradigm of efficiency and effectiveness of each devices. So the specific objective for this research are intensive re-architecture of YOLO 8, focusing on substantial reductions in model size and computational load, and then to ensure that the model maintain high standards of accuracy, precision, recall, and F-score, and rigorous evaluations of the redesigned model using the CASIA datasets to verify its performance under control condition. Okay, so this is our project scope. A true investigation into YOLO 8 architecture, pinpointing opportunities for efficiency enhancement, a series of comprehensive tests on the CASIA dataset to evaluate the improvement in the model performance, and then deployment of the diverse sets of evaluation metric, including the accuracy, the precision, recall, and F-score, to provide the rounded assessment of the model capabilities. Alright, so this is the table show the summary of the previous works. Okay, this study collectively underscore the advancements and versatility of YOLO models. It's demonstrating their significant roles in facial recognition technology, particularly in the edge computing scenarios. Right, so the use of YOLO 8 object detection framework was chosen for this objective due to its strong resilience and also high speed performance. Okay, it's representing the most recent version in the series of YOLO models. The YOLO 8 is renowned for its real-time object detection ability. So from this diagram, this is an architecture diagram, visual the structure of the YOLO model, both prior to and with the incorporating of a shuffle nets, the GS COF, and the large modules. And this illustrates the emphasize the structure, disparities, and areas of optimization. Okay, next is our data flow chart. Okay, this diagram provides the visual representation of data preprocessing pipeline, starting from the data collections, going through a preprocessing, and then end with the input into the models. Okay, this will encompass the many phases of argumentation and normalization that are applied to the dataset. Okay, this is a training process chart. Okay, this chart shows the model learning progress over time, illustrating the decrease in the loss and increase in the accuracy during the training approach. Okay, next is our performance metric graph. Okay, so it celebrates the visual representation, including the loss graph, the precision recall curve, precision recall, F-score, which demonstrate the model performance across a various threshold and criteria. Okay, so for the data set, this research involves a crucial stage of data collection where the main objective is to gather the wide-ranging and diversified data sets that is necessary for our training and highly efficient facial recognition models. So the selected data set is CASIA, renowned for its extensive collection of facial photos. And then a series of data collection is the data acquisition process, dataset characteristic, preparing the dataset for research and significance for model trainings. Okay, and then in our data processing, this is also a vital step in this research process which involving the transformation of raw facial image from the CASA dataset into a format which suitable for efficient and effective process by the YOLO models. Okay, so this stage ensure that the data is optimized for the model training and recognition accuracy. Okay, so from this flow, from this it's illustrate the pre-processing techniques adopted in this project. Okay, for the implementation, the data processing in research is designed process the transform our raw facial images into the optimized format for the YOLO 8 models. Okay, by standardizing, the enhancing, the augmenting data sets, this phase play a crucial role for ensuring that the model training effectiveness and overall accuracy in the facial recognition. Okay, so this figure show the first one is the face detection and the another one is the face recognition in the different environments. Okay, so alright, so we go to our analysis result. Right, so based on this table and based on our experiment, the finding obtained from our experiment has covered the following valuable insight. So the precision, our recall, map, and the F-score consistently high across all the model version, showing a strong and reliable detection accuracy. And then the integration of the shuffle net version 2 into the YOLO 8 result in a notable reduction, okay, in model complexity, okay, and the size. Okay, it's leading to improve the frame per seconds and overall processing efficiency. Okay, so the user did not provide any text. Okay, so the YOLO shuffle, the combination of YOLO 8, the shuffle nets, the GS COF and large model demonstrate the most significant improvement in the performance. Okay, it's achieving the most frame per second and showing its better real-time performance capabilities. Okay, so next is we compare with the CASIA dataset from the core paper, from our benchmark paper. Okay, so the YOLO 8 continuously demonstrate improved performance in all parameters, indicating that the architecture is highly effective for precise facial detection. And then it's significantly the incorporation of the GS-COF and the shuffle nets too, along with the expansion of the model, it did not affect the accuracy. Okay, and the benchmark model exhibits somehow value of the all metrics suggests a little diminished capacity for recognize its certain situation. Okay, so this from this graph, okay, it summarizes the baseline YOLO 8 model, which demonstrate the robust and also consistent training and validation metrics. It's indicating its efficacy on the CASIA dataset. Okay, so the model high precision and recall demonstrate its accurate and dependable detection and classification capabilities. Okay, so for the mean average precision score, the validation of the model consistent performance across a different level of detection complexity. Okay, so the result, this result provide a reliable standard for measuring the features improvement to the models. Alright, so as a conclusion, the examination and the evaluation of the YOLO 8 and its variants provide important perspective on achieving the desired balance between the model efficiency and accuracy. And the study highlight the potential for integrating cutting-edge module such as the GSCOF and the shuffle nets with a large structure to improve the model performance. And this development represent the significant advance in object detection technologies and provide the opportunities for the streamlined and impactful solution for many real-world application. Alright, so this is the list of our references. Okay, that's all. Thank you.
Hi, I am Bayaki Sregar from Universitas Sumatera Utara, requesting permission to present our paper entitled Estimation of Correct Human Body Pose in Floor Gymnastic Movement Using Computer Vision Technology. Human body pose estimation, which involves determining the 3D or 2D position of body parts from images or video, is numerous use in industries like gaming, sports, security, and medicine. Some of its applications are in computer and human interaction, act of recognition, surveillance, image understanding, and in predicting threats. There are several challenges associated with human body pose estimation, including occlusion, variations in clothing, and large variations in human body shape and size. Many approaches have been proposed to address this challenge, including deep learning-based method, which have shown promising results in recent years. Combinations of human joint points can be used to estimate a person's stance. The goal of human body posture estimation is to comprehend how the various body components move in pictures or movies. Combination of in this research, it is designed to use an image or video data obtained from recording using a camera, so that it can detect the movement of the human body pose. Then the data is processed and data matching is carried out, so that get a model of the attitude of the human body. What the researchers did was build a simple detection system for two types of floor exercise based on certain angular measurements from body movement by the person who is used as the object of image capture via the camera. The system built must be able to display appropriate and accurate output in real time and be easy for others to imitate. At a low cost, this system can be used directly by the general public, especially for independent training as a means of testing whether the exercise movement performed are correct or not. In this research, media pipe pose or MPP was used to estimate the 2D human joint coordinates in its frame of its image. MPP creates pipelines and using machine learning to interpret cognitive data present as video. As seen in this figure, MPP uses a blaze pose to extract 33 2D landmarks from the human body. A lightweight machine learning architecture called blaze pose uses a CPU inference to deliver a real-time performance on mobile device and desktop computer. Inverse ratio needs to be multiplied by the pixel values on the y-axis when utilizing normalized coordinates for pose estimation. We employed 16 landmarks from the estimated MPP landmarks, whose indices are 11, 12, 13, 14, 15, 16, 23, 24, 25, 26, 27, 28, 29, 30, 31, and 32, as shown in this figure, to estimate arbitrary pose and motions. The model built in this research to estimate human body pose when doing floor gymnastics in the form of push-up or sit-up movement can be seen in this figure. For the purpose of estimating human stance, MediaPipe offers a pre-built pipeline that combines computer vision and machine learning method. The pipeline creates an output that contains the estimated 2D or 3D pose of the person in each frame from an input video stream or a sequence of photos. The pipeline makes use of CNN to identify the body's major landmarks, such as the joint and limbs. The pipeline tracks the identified key points over time and calculates the subject's 2D or 3D pose for each frame using a graph-based optimization technique. The optimization technique applies physical restriction to the estimate pose, such as joint limits and smooth, using a model of the kinematics and dynamics of the human body. The pipeline generates an output that includes confidence scores for each key point that was identified along with the estimated 2D or 3D pose of the subject in each frame. The selection of landmarks is based on several angles of the body parts, which change position due to the push-up and sit-up movement from the initial position of the body before the exercise movement are carried out. The results obtained from this research are that the model built and implemented using the COCO dataset shows satisfactory result. An example of the result of monitoring and estimation of human body pose for push-up exercise can be seen in this figure. For one repetition of the push-up exercise, it has been determined in the build model that the initialization of the system begins when the respondent, as the object being observed, is in a prone position, which then moves his body up until his arms are in the straight position. Then his body moves back to the position. The beginning is face down so that the body is close to the mat. For one repetition of the sit-up exercise, it has been determined in the build model that the initialization of the system begins when the respondent as the object being observed is in a supine position, with the knees of the feet forming a certain angle, which then he moves his body up until his stomach touches his thigh. Then his body moves back to the starting position, which on his back so that his back is close to the mat. The following is a video demonstration when this research was carried out. It was found that actually 96% of push-up exercise were identified and 80% of sit-up exercise were identified. This means that for every 100 attempts made, the system would on average succeed in accurately detecting 96 repetition of push-up exercise and failing to detect 4 times. Whereas in the sit-up exercise, for every 100 trials carried out, 80 detection success and 20 failures were obtained. The test result from this research can be seen in this table. Uh, sorry. The estimation failure is due to the fatigue experienced by human as monitoring objects who do push-ups and sit-ups, so that their pose forms an angle that is no longer ideal according to the model used. According According on the findings of this research, the following conclusions can be made. The identification model of human body posture using computer vision through video recording has been successfully built with good result for recognizing push-up exercise and sit-up exercise. The accuracy of value obtained certainly still allows it to be refined and open opportunities for further research to include several respondents consisting of many age strata, children, adolescents, adults, and the elderly, and also include female respondents to obtain a model that can apply more generally. Various other types of exercise in floor gymnastics can also be included to enrich research results that can be used directly by the public at an affordable cost. Combining with other technologies is still very interesting to do. For example, with technology that is able to measure the performance of respondent at a certain time using sensor attached to the body. Thank you very much.
Assalamualaikum and hi to all. So today I will present a topic titled Optimizing Dual Training Approaches for Good Face Recognition. So I'm Fatimah Khalid from UPM, Malaysia. So this is my content. I will start with introduction, key problem statement, objective, methodology, the F1 confidence curve, precision recall curve, training result, video prediction output, and lastly the conclusion. So as an introduction, so in modern livestock management, the accurate detection and recognition of individual animals such as goat are essential for effective farm operation. So traditionally, the identification become less reliable and efficient, prompting the exploration of advanced technology like computer vision and machine learning. So this research project focus on leveraging these technologies, where we particularly utilize YOLO algorithm to develop robust goat recognition system by employing both static image and video frame. So the study aimed to enhance the capability of model to recognize goat across diverse environments and situations, thereby contributing to more efficient and precise livestock management practices. Okay, so in this research, okay, we employ two ways of input, okay, training data set. So one is by using static images and the other one is from the video frame. So by extracting the video frame, so we do train to these images, okay, to get which one is the best practice, okay, for the training data set. So the problem statement is where livestock surveillance and identification present significant challenges. So particularly in diverse farm setting with varying lighting condition and animal movements. So for this, a challenge, okay, where they use in a traditional way method, such as manual tagging and branding, are becoming outdated and less reliable. So there is a growing need for automated and accurate good recognition system that can adapt to dynamic farm environment and streamline management processes. So the lack of such advanced system hinder the efficiency and effectiveness of livestock management practice. Okay, so the main problem here is to where traditionally method they use a manual tagging and branding. Okay, and this become outdated and less reliable. So from the problem statement, we get the objective, okay, where we will develop a robust good recognition system using YOLO algorithm, where capable of accurately detecting and recognizing individual goats in diverse farm environment. So secondly, to utilize two distinct type of data set, as I mentioned, okay, we comprise two type of data set, which is static 2D images and the extracted frame, okay, from the video footage. So both we train to get the model effectively. So the third objective is to enhance the capability of models to recognize good across various contexts, including different lighting condition, poses, and movement. Okay, so for the frame extracted, so we get the video, okay, which is in different lighting condition, poses, and movement. So from this different condition, we train using YOLO, okay, to get high accuracy. So from these two type of data set, then we compare the performance, okay, and to get the best result. And lastly, the objective is to contribute to the advancement of precision livestock management practices by developing and implementing efficient good recognition system, okay, by a combination of computer vision and machine learning technologies. So this is the methodology. Mm, uh, in this research, we have two different type of data set. Okay, so the main objective of the research is to get the best data set to be trained. So one is by using the capture image. The capture image is where we capture a 2D image from one goat to another. So for that particular class, there will be a few numbers of capture image which is in 2D. Okay, so the other type of data set is from the capture frame. Okay, so the capture frame means the input will be the video that we are going to test later. So from this video, we capture the frame to be as the training data set. Okay, so we use RoboFlow where we get the video, and then we select the frame. Okay, so this is by using RoboFlow. So not all frame will be extract. Okay, we will choose the best of the good faces. Okay, and then and it depends on the frame per second. Okay, how many frame that we want to extract. So from this frame selection, so the frame selection will be in a 2D image. So from the 2D image, then we do labeling. Same goes to the capture image, okay, where we label the face good and do the filtering. Okay, so here we will have two type of output, two type of training data. So we want to get the optimum, okay, which one is the best for the uh, training data. Okay, so from these two we do this data splitting, okay, where we have a training 60 and validation 40. So from the training and the validation image, okay, both we do the image processing, okay, where we resize the each of the image data, the training data, okay, to be 640 times 640, and we do some auto adjust contrast using histogram equalization. So from the pre-processed image, we do the image augmentation. Okay, so we will have a variety of brightness from negative 20% to positive 20%, and also different exposure from negative 15% to positive 15%. Okay, so from the two different type of training, so the 60% of the data set we will train, okay, using YOLO. So this YOLO will be transferred, and we get the pre-trained weight. So then the validation as well, okay, so we will do the get the safe weight, okay, and then from the safe weight, so we will get both training and validation, we will get the safe weight. So from this safe weight, okay, we do the testing, okay, so the model that we train, okay, we will test, okay, to the validation images, okay, and to which to predict, okay, the prediction, okay, to predict the face good, okay, and lastly the video testing will be a test, okay, and we will get the output testing, okay. So the project uses YOLO version 8.5 for good face recognition, and chosen, why do we choose this is because of the efficiency and the performance. So the hardware that we use is Intel Core i5, okay, -10210U, okay, with a base clock speed of 1.6 gigahertz and max turbo boost speed of 2.11 gigahertz, 8 gigabyte memory, and using the NVIDIA GeForce MX350 GPU. So the software that we use is Google Colab. Okay, we run all the data, okay, using Google Colab, okay, with a standard of NVIDIA T4 GPU. So the training process utilizes transfer learning from the original COCO dataset, okay, to enhance model efficiency and performance. So we do train, okay, to the COCO dataset. Okay, from this we transfer the weight, okay, to the our own data. And the pre-COCO trained network weights help in model convergence and generalization. Okay, so as in the framework, the image is resized to 640 times 640, and the batch size that we use is 16. Okay, and the training patient is set to 50, allowing the training to stop if there is no improvement. Okay, we set the training patient to 50, so that if there is no improvement, okay, on the validation matrix, okay, it will stop. And this is also to prevent the overfitting. So the EPO size is 120, okay, to get the best result. So this is the F1 confidence curves for both capture and capture image and also capture frame. So this is the capture frame and this is the capture image. Okay, so it reveals a robust performance for both dataset training process, and with capture frame dataset exhibit slightly high effectiveness. So at a confidence threshold of 0.67673, okay, the capture image data set achieve a commendable F1 score of 0.87, okay, indicating that a balanced trade-off between precision and recall as well. So in contrast, for the capture image dataset surpasses this performance, attaining an even higher F1 score of 0.88, okay, at a confidence threshold 0.466. So it's signifying superior precision recall balance. So notably, so capture dataset achieve its high F1 score, okay, at a lower confidence threshold, okay, suggesting greater confidence in the classification of the capture dataset. So means that the capture frame is more better, okay, compared to the capture image. So this is the precision recall curve, okay, and this one is the capture, and this one is the frame frame capture frame. So from this figure, it shows a comparison of good face detection based on precision and recall. Okay, so the precision recall curve for class with average score 0.903 for the capture image and 0.919 for the capture frame. Okay, and in intersection over union threshold 0.5, okay, indicates strong performance for both dataset, while capture frame dataset achieve a slightly higher precision and recall compared to capture image dataset. So means that the capture frame dataset marginally superior performance suggests better classification accuracy and also the coverage of instance. Okay, so this is the conclusion, okay, the summarization of the training result. Okay, by using capture image, the precision is 90.5, okay, compared to the capture frame only 89. Okay, so the capture dataset generally outperform capture image dataset in terms of the recall and MAP 50, indicating that the model trained on video data is better at accurately identifying good faces, okay, localizing them and achieving a good balance. However, capture image dataset with higher MAP 50 95 suggests that it has more robust generalization to different scenario. Okay, so the finding is like in here. So there is not much different. Okay, but the difference is on this one. So this is a few series of video, okay, with two class. So this one is for good 7-220, and this one is for good class 30-22. So from this series of video, okay, so it shows the correct identification, okay, with confidence level of 0.87 screenshot. Okay, so this is for 0.05 second, so it shows that it can be identified correctly. Okay, and 0.07, 0.1512, okay, and 0.29. Okay, so same goes to here. So it shows that the prediction, okay, is correctly identified on a few taken duration, okay, for the second class of good. So as a conclusion, challenges were encountered in achieving accurate prediction from the YOLO version 8 model when applied to lower quality test videos with dynamic condition diverging from well-calibrated training data. Okay, so means that the video, okay, the test video have a dynamic condition, okay, and it is diverge from well calibrated training data. So that is the most challenge, okay, for achieving accurate prediction. Okay, and despite pre-processing techniques, prediction accuracy remain suboptimal due to variation in background lighting and motion blur. Okay, and implementing a data augmentation strategy by incorporating frame from test video into a training dataset notably improve the model prediction performance. Okay, and showcase. So the findings shows that by using video frame capture for training data is better, okay, compared to the capture image. Okay, and caution, it is necessary to prevent overfitting to specific test video characteristics, emphasizing the performance of regular validation on diverse dataset to assess general capabilities. Okay, so ongoing experiment, okay, with diverse technique including adjustment to model architecture and hyperparameters will further enhance the model robustness across varying conditions, highlighting the dynamic nature of model development in response to real world challenge in good recognition for precision livestock management.
Assalamualaikum warahmatullahi wabarakatuh. Good morning. Introduce myself. My name is Muhammad Abdul Hashim. Along with Team IDER are Mrs. Sri Mervani Hardi and Mrs. Amalia. We come from the University of Sumatera Utara, Medan, Indonesia, Faculty Computer Science and Information Technology. Here I will present our research entitled Certainty Factor Method in the System for Determining the Eligibility of Bride and Groom Candidates in Improving Marriage Service Procedure Standards at the Tebing Tinggi City PPKB. Okay, First, I will explain background behind more for first research. This done because importance inspection to candidate bridge because marriage is an important moment in life. Somebody decision to marry affecting society, the environment, as well the two individuals who will marry. Success wedding influence how understanding partner to factor possible risks influence connection. So from that we say, so from that seed and check candidate partners are very important, especially regarding medical history and examination, his health, his life, and his personality. So from that importance, standard procedure, service marriage, procedure, program standard, service marriage, expect capable, lower level risky partner, find from faith, health, nor psychology, before marriage so that can do coaching. Inspection this covers a number of criteria including age candidate, bride and groom, test psychology, test health, and risk disease everything. Okay, furthermore, formulation problem for study this is one manual inspection of prospective brides and grooms at the Tebing Tinggi City PPKB service cause the possibility of error resulting in less efficiency and transparency in the process. And two, the lack of health information that the prospective bride and groom have can result in inadequate assessment of the prospective bride and groom's risks during the examination. Okay, furthermore, scope problem from study this among in one, using the certainty factor method to recommend prospective brides and grooms. To the data used in the research was taken from the population control and family planning of planning service of Tebing Tinggi City as the agency under which three handling the examination of prospective brides and grooms. The dataset used is brides and grooms candidates. 4. The recommended parameters for prospective brides and grooms taken are age, health tests, including HIV/AIDS test, chest and stomach circumference for women, congenital disease, weight, height, and drug tests and physiology tests. 5. The output from the result of the prospective bridge examination is to find out whether the prospective bride and groom are at risk or not at risk to provide a marriage control card. And the last, the program is designed on a website-based application. Website-based application use PHP language and the coordinator framework. Okay, furthermore, the objective from study this expect the first predicting health risk in prospective brides, two providing health guidance recommends to prospective brides, and third improving the quality of the examination process with a system for determining the eligibility of prospective marriage. Okay, furthermore, analysis problem from study this is the taking the Tebing Tinggi City PPKB service still experience challenge in efficiency and effectiveness of the inspection process to candidate as bridge who is still manual. Limitation source power making the process come to life not enough maximum and efficiency, so can potential in accuracy inspection. Okay, here I will explain a little about base the theory from research. Conducts the sure inspection to candidate the first bridge there is expert system. First, the expert system, system expert atau expert system is system used for adopt knowledge from an expert in take a decision to get it finish something moderate problem identified. System expert expert system or system expert can give something information and prediction to user in identify something. Okay. The second, there is certainty factor method. Where is the method? This is method create for give mark confidence to result and from something based on mark confidence given my expert. This is method expect can give description something test based on Martha's expert in diagnose. Okay, furthermore is relevant works in research. Okay, here I will explain architecture from study. The first, the user works in status user account candidate bridge will do fill the filling in the candidate data, bridge and group, then do it charging health screening for C-RIX illness experienced by the candidate, bridge as reference moment, inspection health candidate, bridge and group. Next candidate bridge field survey with psychology. Later, result identification become reference moment counseling with psychology. Okay.
Assalamualaikum and good day. Okay, today I'm going to present my works that related to the hybrid ensemble. Okay, as you can see, this is my title, the CCAR, a hybrid ensemble feature selection framework for machine learning based phishing attack detection system. Okay, I myself, Muhammad Denal Hafiz, and with my researcher, which is Semi Milad L Flash. Okay, we are from FSKTM UPM. All right, without further ado, let us see our agenda. Over here, we have introduction, okay, problem statement, objectives, followed by this literature review, methodology, result, and discussion, and we end up our presentation with the conclusion. All right, let us start with the introduction. Okay, although our cyber defense system are continuously getting more complex and sophisticated, all right, social engineering cyber attacks targeting these people have increased as a way to get around these defenses. Okay, we all know that phishing is the most common and the easiest form of cyber attacks, and it is also the most effective one. Okay, despite of this continuously evolving anti-phishing technology already in place, some messages still get through, and therefore leveraging of this on this existing technology become vital to defend such attacks. Okay, let us focus on the problem statement. Okay, the previous anti-phishing detection studies focus on proposing novel features or optimizing classification algorithms are insufficient to improve the classification accuracy. They neglected the importance of developing an effective and systematic feature selection technique and framework to overcome the inaccuracy detection of phishing attack. Okay, based on that, here is another sub problem. Okay, which is the incomplete feature selection method due to the lack of feature cutoff rank identifier to identify a highly effective and compact set of baseline features for phishing attack classification. Okay, also, okay, they face this problem, which is the ineffective feature selection framework due to the lack of systematic approach to optimize the baseline features that are most effective for machine learning classifier. All right, based on the previously mentioned problems, okay, this is the objectives of this research. Okay, number one is to propose an algorithm that can identify the feature cutoff rank whereby only the features positioned above the cutoff rank will be selected for phishing attacks classification. Okay, the second one is to propose an effective, okay, or we can say it's a systematic feature selection framework. We call it a cross correlation attribute ranker, or CCAR, in order to optimize the baseline features, okay, for machine learning phishing attacks classifier. Okay, in this research we done through the literature review, okay, a number of papers, which is latest one, ranging from 2010 until 2022. 2022 around that. Okay, all the papers will be read, and we can identify the problem that being faced in the current paper or research done by the researcher around the world. Okay, this is the summary. What you can see, we focus on the approach that being used by them. Okay, also we try to find what is the findings. Okay, and we also list out several limitations faced by the current um, research on phishing attack classification. Okay, this is in total we have 8 papers. Okay, the one which is highlighted in blue. Okay, it is our main anchor paper, which is we focus on this paper in order to find all the weakness or the uh, limitation on this paper, and then we try to improve this paper and compare with the existing uh, paper in terms of solution and like the performance evaluation related to the accuracy. Okay, when done all this survey, okay, we're not only focusing on 8 papers. Actually, we have more than that, but the 8 papers is the most related to all to our research. Okay, in summary, what we have found is that for the literature that being done by us is majority of the current filter measures based feature selection studies in the phishing detection field are lacking a systematic approach to identify the optimal cutoff rank. Okay, and then several conventional feature rankers are employed, for example, like information gain, relief F, and wrapper method. Okay, although the wrapper method achieves higher detection accuracy when compared to the other methods, okay, yet the wrapper method is indeed computationally more intensive. Okay, we need more power to process it, okay, as compared to the other feature rankers.
Assalamualaikum warahmatullahi wabarakatuh. Thank you for having me and the opportunity so that today I can present my research, namely hybrid algorithm using CNN and LSTM to improve performance in skin lesion image classification. My name is Indilar Sikaputri. My research supervised by my supervisor, Dr. Amalia, and Professor Dr. Taufik Fuadi Abidin. As an introduction, skin lesions are a condition of part of the skin that have abnormal growth and appearance. Early detection of skin lesion will be very important, as skin cancer will have a better prognosis if detected early in its development. Skin lesion detection can be achieved through multiple methods. The first one by visual inspection of lesion characteristic without the aid of any instruments. The second one, by dermoscopy. This device, a specialized magnifying lens, significantly improve dermatologists' diagnostic capabilities. And the third one is by using artificial intelligence. The problem statement: dermoscopy has enhanced accuracy in diagnosing the early stages of skin cancer, but persistent challenge of relatively low accuracy rates still occur. Although a dermatoscope is used, the identification of skin cancer remains imperfect. Artificial intelligence has emerged as a potential solution to address this issue of dermoscopic image-based diagnosis. This is the literature review to support my problem statement. Andrew Cassini in 2023 said that AI software shows significant improvement in cancer detection. AI software yield outstanding results, accurately identifying 55 cases of melanoma with an accuracy rate of 100%. Meanwhile, Hansel et al. In 2018 compared the diagnostic performance of CNN with a large international group of 58 dermatologists, including 30 experts, where in this result, the result of the CNN outperformed the result obtained by the expert. A comparative analysis indicates that the mean score achieved by the CNN is greater than the mean score attained by dermatologists. For the previous research, the research by Sethi et al. In 2022 aims to classify 7 skin lesions using CNN. The research finding indicates that the CNN model has a higher accuracy rates of 95.18% compared to other classification method previously proposed. Meanwhile, the research by Sarkar in 2021 explained various taxonomies concerning deep learning methodologies, highlighting of potential combining of two algorithms. One of the potential combining of two algorithms is by integrating of CNN and DLSTM. Study by Islam in 2020, the research involving the integration of CNN and LSTM for the COVID-19 case study that detected image data in the form of X-ray of COVID-19 patients. In this research, the percentage result of the performance of the CNN and LSTM surpassed the CNN algorithm result. The goals of this research are: the first one, early detection of the skin lesion based on their classification to determine whether the skin lesions are cancer or non-cancerous. The second one is to improve the performance of skin lesion image classification by their accuracy, sensitivity, precision, and F1 score. My research contributions are creating a CNN LSTM network that works together to automatically aid in the early stage of cancer or skin lesion disease. The second one is to classify skin lesion using image from a chosen dataset that include 2,736 images. The third one is an experimental analysis is provided in terms of accuracy, sensitivity, precision, F1 score to measure the performance of the proposed system. The dataset employed in this study are combination source from PAD UFAS 20, released in 2020 via Mendeley repository, and the International Skin Imaging Collaboration dataset that taken from Kaggle with total 2,736 sample images. The dataset categorized from 6 distinct classes of skin lesion. The first one is actinic keratosis. The second one, basal cell carcinoma, malignant melanoma, melanocytic nevus, squamous cell carcinoma, and seborrheic keratosis. Among these classes, 3 are classified as skin cancer, and the other 3 as non-cancerous. This is the sample image of the skin lesion, namely BCC, SCC, ACK, MEL, NEF, and SEK. Just like I mentioned before. And now let's move to the methodology. We can see the image here, the summary of the process of the research. In this study, we conduct ordering dataset based on their class. Before image resizing to dimension 300 multiple 300 pixel. Regarding data pre-processing, a stratified sampling strategy was employed to randomly select 100 images from each class in the dataset, resulting 600 class selected image. Subsequently, each image was augmented through 4 variations: horizontal flipping, rotation, translation, and shear transformation. The augmented data from the new dataset, resulting in 500 images in every class and a total of 3,000 images overall. Data augmentation also served to mitigate the risk of overfitting, enhance model performance, and bolster generalization capabilities. Furthermore, the dataset divided into training and validation using an 80 and 20 ratio, allocating 2,400 images for training and 600 images for validation. And this is the image for illustration of data splitting that I described before. And this is the table of partitioning of used dataset. This is an architecture of the proposed model. From this figure, we can see that after the data has been pre-processed, the processed data proceed into the CNN LSTM network. This architectural framework initiates with traversal through convolutional and pooling layers. Each CNN block comprises a convolutional layer followed by a pooling layer coupled with batch normalization aimed to enhance training stability and expediting convergence. Following convolutional and pooling operation, the resulting output undergoes processing in a dropout layer to prevent overfitting. The output from the convolutional layer is sent to the LSTM layer, which stabilizes the learning process and functions as a classifier. By utilizing the dimension expansion technique, the output from the convolutional layer is transformed into a two-dimensional vector format, serving as input for the LSTM layer. Following the LSTM processing, the image undergoes further further processing in the fully connected layer to predict its classification into one of the predetermined skin lesion categories. The result for the CNN model, the accuracy training result is 99.87% and validation accuracy is 88.83% respectively. Similarly, the training and the validation loss is 0.059 and 0.3 respectively at epoch 20. The result of the CNN and LSTM model, the training accuracy is 95.71% and validation accuracy is 91.83%, respectively at epoch 20. Similarly, for the training and the validation loss is 0.2 and 0.32 respectively for the CNN and LSTM model. When comparing the CNN LSTM architecture to the CNN architecture, higher training score and validation accuracy were obtained. Based on the observation from above, we can define that the validation accuracy graph of the CNN LSTM network exhibit greater stability compared to the CNN network beyond epoch 15. So we can see that CNN LSTM is more suitable for a long-run execution than the CNN architecture. Notably, the CNN LSTM network exhibit minimal fluctuation in gradients after epoch 15, indicating a mitigation of the vanishing gradient problem. This attribute contributes to an improved learning process in comparison to the CNN model. This is confusion metric for the CNN. We can see the true positive, false positive, true negative, and false negative for each class of the CNN model. And this is the confusion metric of the CNN LSTM. We can see also the true positive, false positive, true negative, and false negative for each class of the CNN LSTM model. For the result table comparison, the proposed model achieved an accuracy 91.83% on the validation set, which indicate better performance in comparison to the classical CNN model, which achieved an accuracy of 88.83%. These results are both obtained after stopping at epoch 20, and the precision and the sensitivity values of the proposed model achieve 92% and 91.85% in comparison to the classical CNN model, where the achieved results are 88.93% and 88.73%. A higher precision values indicate the fact that the percentage of false positive result is low, which is achieved with the proposed model. Furthermore, a higher sensitivity or recall value of CNN LSTM network translates to the fact that the proposed model can detect most of the true positive instance compared to the classical CNN model. The F1 score is an evaluation metric that combines precision and sensitivity in the confusion metric, which take both the false positive and false negative values into consideration. In this result, F1 score of 81 point 91.85% is achieved by CNN LSTM network in comparison to the CNN network, which is only 88.75%. It means the proposed model has a better balance between precision and sensitivity. Conclusion. CNN is powerful for image classification, but still have limitation in vanishing gradient problem and stability during model training. Second one, a hybrid CNN LSTM network for simulation classification use CNN as a feature extractor while the LSTM assists in the learning process and classification. The third one, the hybrid CNN LSTM demonstrate an improvement result in accuracy from 88.83 with the CNN network to the 91.83% with the CNN LSTM network. Additionally, the developed CNN LSTM obtained 91.85% sensitivity, 92% precision, and 91.85% F1 score, outperforming the CNN network, which obtained 88.73% sensitivity, 88.93% precision, and 88.75% F1 score. For the future work, the first one is increase the sample image size. The sample image size in this research is relatively small. So the next researcher or the future researcher maybe can use more sample image from the innermost dataset. The second one is classify more than 6 types of skin lesion. In the future, researcher may be able to study a wider range of skin lesion using a diverse dataset also. The third one, enhance and modify the model architecture. Future researchers can improve the performance of the CNN and LSTM network by enhancing or fine-tuning the current model architecture. And the last one is compare the model performance with the dermatologist. It is important to compare the model performance with the dermatologist. Therefore, the future study should include a comparison result from the model, AI model with the dermatologist. That's all my presentation. Thank you. Thank you for having me. Thank you very much.
Assalamualaikum and thank you. Today I'm going to present my research work on enhancing prediction of Malaysia interest rate trends through artificial intelligence. So my name is Azizul bin Abdullah from the Faculty of Computer Science and Information Technology, University Putra, Malaysia. So we know that in global economics, okay, the ability to forecast financial trends is very important because it gives an implication for the national policy making investment strategies, and also financial planning. So among these trends, the BLR in Malaysia stand out as a very important indicator that influence the flow of the nation economic vitality. Traditional method that we use for forecasting have a long relied on a linear model that is often for short in capturing the complex interplay of factors that shape economic outcomes. And with the advance of AI and also machine learning, have these two has bring the fourth sophisticated tools capable of to dissecting this complexity through the data-driven insight. So in this study, we have ventured beyond the conventional econometric techniques, tapping into the transformative power of the artificial intelligence to predict the future cost of Malaysia BLR. So our research is basically is promised with these tools, specifically the LSTM networks and random forest algorithm. And we know that both of these are basically renowned for their prowess in pattern recognition within the large data sets. So for this model, okay, we use the historical BLR data from 1997 to 2023. So the ultimate aims is not merely to achieve a retrospective understanding, but to project this understanding forward, crafting vision of BLR trajectory for the next 5 years. So based on the previous work, okay, from our literature, we can see that some of the literature, some of the researchers have done, have used this AI, right, in their studies for forecasting. For example, like Muhammad Shari have worked on to see the influence of the BLR on the capital structure of the Malaysian companies from 2005 to 2015. Okay, and then Tan have looked into the dynamic between base lending rates, housing prices, and also they have collective impact. Okay, and their collective impact, okay, on the residential housing activities in Malaysia during the early of 2000. Okay, Sanusi have explored the development of basic artificial neural network between models for forecasting Malaysia in sample growth domestic product (GDP). Widarni and Wilantri have examined the impact of education and health investment on Malaysia economic growth from 2000 to 2019. They have using the quantitative threshold autoregressive methods to demonstrate that both the education and health are crucial investment in the human capital, okay, that can influence the economic performance. And then Muhammad Damit, okay, focus on the Malaysia supply construction sector GDP from 2015 to 2023. Okay, so he also utilized the correlation and regression analysis. Okay, all right, and we know that with the ability, with the computing power and also the data availability, this machine learning model have come to the picture. Okay, because of the the flexibility and non-linearity of the models such as SVM, random forest, and neural networks has been explored in the financial context. Okay, so this model has offered a fresh perspective on pattern recognition within economic data, translating the limitation of traditional economic model. So in our research, okay, we basically have come up with a method how we should be able to predict, okay, the BLR using based on the LSTM and also the random forest model. Okay, so in data preparation and normalization, what we do, okay, we use the data set, okay, from the Central Bank of Malaysia, okay, and we need to clean this data set to focus on the BLR. Okay. And then for the model development and training, so for the LSTM model, okay, so we have used the model with the Adams optimizer, okay, and aims to minimize the mean square error MSE using the formula. Okay, and then we use the random forest model, leverage lag BR features as predictive inputs, utilizing an ensemble of decision tree to model complex relationship. Okay, and then the model performance will be enhanced, okay, through the bagging and feature randomness, right? And for the performance metrics, okay, we have three here, okay, RMSE, mean absolute error, MAE, and also R square, based and using this formula here. Okay, in our experiments, okay, we apply the LSTM and RF model to the historical data, right? So we each chosen for their unique ability to decipher complex pattern and trends. So here we have three experiments. Okay, the first experiment is LSTM model forecasting. Okay, the second experiment is random forest evaluation, and the third experiment is extended for forecasting with LSTM. Okay, for the next 5 years. Okay, so we have result, okay, from experiment 1, 2, and 3. So from our study, what we can say, okay, from the experiment 1 and experiment 2, okay, as you can see in the result, okay, so we can say that in table 1, okay, the nuanced insight into the model predictive capability within the Malaysian economic landscape, okay, in our forecasting for BLR. So in the LSTM model employed in experiment 1 has demonstrated considerable proficiency with the RMSE of 0.2747 and MAE of 0.1169 and R square of 0.9302. So this result not only confirm that LSTM adaptness at unraveling temporal pattern, but also is suitable for economic indicator like BLR, which are influenced by confluence of factor evolving over time. And in figure 2, you can see now, these are the result experiment, okay, from the experiment 1, okay. So it shows that the LSTM tendency to smooth data in evident, okay, especially when it's handling the peak and true, which consistently underestimates, okay, and overestimates respectively. So this pattern is basically smoothing in the particularly noticeable in the year 2021 and 2022. Okay, so we can say that the LSTM efficiency can be contextualized within Malaysia economic dynamics, where fluctuation in BLR are often reflective of the broader fiscal policy, inflation rates, and also the international economic trends. Okay, so the LSTM have the ability to internalize and predict based on these temporal sequences, underscore its potential as a tool for the short to mid-term economic forecasting, right? So as we just mentioned that, okay, from the experiment 2, okay, the exploration with the random forest model, okay, it yield an even more robust performance as evidenced by the RMSE 0.1119 and AME 0.0447 and R square of 0.9836. Okay, so the random forest model superior matrix eliminates the strengths in capturing the non-linear relationship and complex dependencies inherent in the BLR data. Okay, so the model success suggests that significant utilities in setting the factor on influencing the Malaysia bailout. Okay, we can see that its ability to effectively model complex interaction between various predictors make it an invaluable asset for understanding the underlying dynamic of Malaysia economy. Okay, so from the result in experiment 2, okay, as shown in figure 3, the model have captured the direction of the data trends, okay, but is notably less precise during the peak and through, especially in 2020 and 2021. Okay, so this indicates that while the model understands the general pattern of BLR, it may struggle with the accuracy of sudden changes, suggesting a need for further refinements to improve its performance in forecasting the metrics and the metrics volatility. Okay, in contrasting to the two model, okay, LSTMs, okay, temporal sensitivity of particularly advantageous for forecasting period closely following the training data set, allowing for dynamic adjustment for short-term economic shifting. Conversely, the random forest model with the emphasis on non-linear patterns have broader consideration of economic indicator, might offer more stable and robust forecast over longer horizon with a different set of consideration for model interpretation. So then we go for the next experiment 3, which is where we study the in this study, we venture into the realms of future forecasting, right? By the extending the insight gained from LSTM ability to interpret the historical BLR data to predict the trajectory of Malaysia-based lending rates over the next 5 years. So in this exercise, okay, uh, it's, it's very important that the accurate long-term economic forecasts are very crucial tools for policymakers and investors to prepare for their future economic condition. So the LSTM model forecast for the year 2004 predicted at BLR 6.9%, which upon comparison with the last update information in 19 January 2024 show that it's close proximity to the actual overall BLR reported at 6.67%, with the uh, BFR at 6.65%. Okay. So as a conclusion, we can say that uh, the model that we use here is basically based on the experiment 3. Okay. It shows that the LSTM prediction for 2024 reported a BLR of 6.9%, which closely aligned with the actual figure updates in 19 January 2024, indicating a BRR of 6.67, and with the base financing rate BFR of 6.65%. So it's actually the value can validate that this model has predicts with the quality, okay, as a potential AI forecasting, okay, in the context of Malaysia dynamic economy. Okay, thank you. That's all for my presentation. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Maslina binti Zulkifli. Today, I am going to present my research entitled Deep Learning-Based Breast Cancer Detection, a multi-scale approach with dual attention for accurate lesion segmentation. So this presentation is recorded for the International Symposium on Artificial Intelligence and Internet of Things in Perspective from Indonesia and Malaysia, with collaboration from University Putra Malaysia and Universitas Sumatera Utara. So this is the outline of my presentation today. Introduction. So, breast cancer is considered a lethal disease and is most frequently diagnosed in women worldwide. Due to lesion size, texture, and a different variation of shape and ambiguous boundaries of lesions, and low signal to random noise in ultrasound images. Therefore, an accurate breast lesion segmentation is an open challenge for the research community that helps medical specialists diagnose breast cancer early. So, the problem statement, we have three. Number one, it is difficult to segment some breast lesions due to their blurred and irregular edges. And the second problem statement is the texture features in medical images are easily extracted by CNN, but edge features are also easily ignored by them. And lastly, in the original UNet algorithm, due to the fixed receptive field of the convolution kernel, the diversity of features is lost. So the objective of this research is to capture irregular and fuzzy feature of breast lesion, then to capture the edge features of breast lesion, and lastly to accurate segment with different scale of breast lumps. So this is the hardware scope and also software scope for this research, where we use an Mac OS operating system and Python programming language and Miniconda for development environment. And the technique that is used here is the UNet. So for literature review, the main key paper that is referred to in this project is the MDA net, a multi-skill dual attention based network for breast lesion segmentation using ultrasound images, where the methods that is used in this key paper is a multi-scale fusion block and a hybrid of channel-based attention and lesion attention blocks. So the result is the breast lesion images regions of interest are located better with clear boundaries and accurately segmented. So they use the UDIAT and BUSIS dataset. So the methodology used in this research is as shown in this flowchart, where first we will apply pre-processing technique such as removing background, removing noise, and enhance the image. And then we will implement the MDA net model with loss function. And we will compare with the previous proposed model. And finally, we will do the evaluation. So this is the image pre-processing technique, where we will use discrete wavelet transform. So the image is decomposed into low frequency and by wavelet transform. And the low frequency and high frequency components are respectively enhanced by adaptive transformation called Silahi and homomorphic filtering, which can effectively limit noise enhancement and avoid over enhancement to maintain image detail information. And finally, the enhanced image is obtained by inverse wavelet transform. And the result of this is an enhanced image. Next, the enhanced image will be used in the UNet model. So the classical UNet model is also based on encoder-decoder phase architecture and comprises of three different parts. Number one is the encoder part, number two is the decoder part, and number three is the skip connection part. And in the proposed architecture, the MF block is embedded as a replacement in the encoder path of the proposed work to address receptive field limitation issue. And then the dual attention mechanism is introduced to combine lesion attention block with channel attention based block to improve ability of discriminate expression. And finally, the skips connection part bridges the encoding path to the decoding path of the network, where it will propagate useful information and clarifies outcome. And then in the loss function, the breast lesion pixel holds a smaller region of interest in ultrasound images concerning healthy tissue pixels and create class imbalance issue. Ultimately, the lesion region of interest is missed or partially detected. Generally, dice loss is a function that directly optimizes towards evaluation metrics. Therefore, the negative effect of class imbalance is reduced to introduce loss function. So we are using two types of dataset. Number one is the UDAT and number two is the BUSIS. The UDAT is a dataset shared by UDAT Diagnostic Center of Sabadell, Spain, and it has 109 images that belong to a benign tumor and 54 images belong to malignant breast tumor. And for the BUSIS dataset, it is provided by the Hospital of Harbin Medical University and Hospital of Qingdao University and Hospital of Hebei University. It has 562 ultrasound images with unclassified between benign and malignant lesions. So this is the three evaluation metrics that it's used in this model. Number one is the dissimilarity coefficient. Number two is the checkered similarity coefficient. And lastly, the precision and recall. So this is the result after training for 200 rounds. So this is the result. The first one is the result for the loss function, and then the second one is the result of the dice function. And this one is the result for the jacket function, and this is the result for the precision and recall. So for the UDAT dataset, we compare our algorithm with the existing algorithm called MDANet. So for dice, checkered, and precision and recall, the proposed method scores better than the existing method, which is the MDANet. To make it more universal, multiple test images is used to obtain the variance and standard deviation for comparison. As you can see in some of the comparison, the proposed method performs better. But for the standard deviation and the variance, mostly it does not perform better than the existing technique. So for BUSIS dataset, our proposed method performs better in terms of dice, jacket, and precision and recall. So the conclusion, the purpose of this study is to propose a framework for applying deep learning techniques in the field of breast lump segmentation. The proposed architecture where the multi-scale fusion block adds lesion attention, channel attention, and dual attention blocks. Focuses on more meaningful information of regions of interest in breast lesion images. Dataset has been trained and tested for breast image segmentation for different scale lumps, and the result has been evaluated based on standard parameters such as dice, checkered, and precision and recall. For future works, we are planning to add this application to the current network It is also more crucial to update the database more regularly so that we have more images that we can use as training, where we can obtain a variety of data, including breast cancer picture angles, lighting, and so on. And we can also improve the algorithm's efficiency by reducing the training and segmentation times. So this is the reference, and thank you very much.
Assalamualaikum and good day everyone. Today I'm Faiza Maro will present my group's research entitled Real-Time Shadow Depth Cube Touchless and Gesture on Desktop Virtual Reality Effective Control using F-Light Model. Based on detailed observation, there are issues that arise among students, namely users who use the Electro VR application while in class. In general, users experience difficulties in selecting and manipulating objects in virtual environment. At first, the user had difficulty grasping the magnetic bar, but after some modification to solve the grasping issue, then the user experiences difficulty in moving the magnetic bar towards the solenoid, where the magnetic bar easily drops when moved. Not only that, in fact, the user also experiences difficulty in locating the magnetic bar into the solenoid accurately. These issues emerge due to an improper illumination model. A previous study by Chakraborty ETL 2015, Al-Hakami and Tusabian 2019 found that virtual illumination model could affect virtual queue and enhance control efficiency. Susato and Martin's study 2023 also shows evidence of the potential use of illumination in VR, emphasizing in depth understanding of human perception of illumination and its impact on human behavior in a variety of settings and environments through different illumination conditions. Moreover, according to Rafa 2020, illumination model can enrich the graphics through adjustment to reflective and refractive material properties. For example, Frank 2019, Rahman and Kelly 2017 highlighted that the Lambertian model is used as guidance in producing shading on objects because Frank 2019 found an illumination simulates indirect illumination on objects. Illumination is related to visual cues through depth cues. Ping PPR 2019 created a physical-based technique that involves physically arranging hallway lights in a virtual environment to give significant depth cues for object distance issues. Initially, this study employs hallway illumination model by Ping 2020 for virtual environment. However, user difficult to grasp, inappropriate cues made user unable to estimate the position of 3D hand with the object while grasping. But after some adjustment made, then user difficult to locate the object and the object drops easily when moving as well. These problems might be occurred because of inappropriate illumination model use. Hence, further investigation and experiments need to be conducted to identify appropriate illumination settings in order to rectify the problems. Therefore, this study was conducted to model illumination environments for shadow depth cues to grasp virtual objects effectively. So this study used a quantitative method. There are 4 experimental studies with different illumination settings in a virtual environment, and a variety of physical illumination were conducted. The think aloud method and observation were also applied during the experiments to provide clarity on the notes taken during the observation. These experiments were also video recorded. For analysis, statistical on successful rate was used to support the findings. Based on the settings and procedures on the screen, an on-site test is carried out. 2 cameras were placed on the side and in front of the user to record the user's behavior, voice, and facial facial expressions. So based on pings, basically 4 sources of illumination and the placements of directional light to ascertain the precise match real-time shadow depth cues as shown on the screen. Nevertheless, to model the most appropriate illumination with minimal illumination sources for non-dynamic VR, the experiment started with 1 source of illumination and will be added gradually. So an illustration of the layout of illumination models used in these experiments is as shown on the screen. The use of sources of illumination is limited to 3 instead of the 4 recommended by Ping. And this is because only 3 sources of illumination have caused glare on the object even at minimal intensity. The best illumination for electro VR was shown in figure C, and this situation will be explained in details on the next slides. In these 4 experiments, use the same user because if users with familiarity still experience difficulties, it means that non-familiar users will also experience the same problem. So in this case, however, at the beginning of the recruitment, 2 groups of novice and experts are chosen to represent with the portion of 50% and 50% each. Okay. So based on the experiments conducted, the finding shows that it is possible to enhance the touchless and gesture VR performance of real-time shadow depth cues by adjusting any component of the image depth, including shadows and illumination. Shadow depth cues significantly affect the accuracy of real-time touchless and gesture as illustrated in figure A, B, C, and D on the next slide. So picture A show outcome of experiment 1 and 2 in appropriate shadow depth cue from user's point of view and ineffective control occurred. Meanwhile, figure B show outcome of experiment 3 whereby too bright with unclear shadow depth cue and glare on solenoid caused with ineffective wraps and locate. For picture C, show outcomes of experiments 4 without light, better but jagged shadow depth cue with F light and dark environment and also easily drop. So this slide is without light 1. Okay, and then the last experiment is the last picture is with light 1, precise place match with smooth shadow depth cue, serve effective control via F light with adjusted light 1. So based on the experiments, there are issues of pink illumination. So based on detailed observation during the first and second experiments with one light relay control issues, particularly when users conducted grasping operation under low illumination condition, even though the shadow was clearly visible and provided a strong visual cues. Moreover, as the surface of the solenoids is typically smooth in real-life scenarios, nonetheless, it was observed that the edge of the shadow cast exhibited noticeable jaggedness. So to rectify the issues, following Pink's layout, one light was positioned in front of the first light, while another was positioned behind the first light. The result demonstrated that the addition of light did not improve the circumstances. On the contrary, an excessive illumination not only resulted in inconsistent occurrence of the effective control issues in different levels of ambient illumination, but it also created glare that hindered users' visual perception of objects despite some modification to its intensity. So, due to aforementioned challenges, the front light, known as F light, was then relocated and mounted on the virtual camera while the backlight was taken out. Interestingly, once the position of the generated shadow cue was altered, the perception appeared more realistic from the user's perspective, whereby shadow cue was positioned slightly behind the objects, resulting in a more organized and neat appearance of the task. And the way in which things are organized help users in focusing more effectively on the task and abstract concept that Electro VR aims to highlight. To conclude, F-Light produces a precise shadow depth cue of objects. Amazingly, improved shadow depth cue helps users to grasp objects with greater effectiveness. However, issues on moving and locating operation sometimes occur. Therefore, Light 1 was added. Interestingly, the initial incorporation of light, referred to as Light 1, significantly enhanced the luminosity of the virtual world with adequate intensity. Finally, better shadowing is produced, which also improves the effectiveness of moving operation. In addition, it also enhanced the locate operation implicitly. The equation on the screen is used to calculate illumination of F-light model and light 1 with adequate intensity. And statistical results were also obtained to strengthen the aforementioned findings. And the use of light 1 only. So based on the table, for condition light 1, no F-light. So the use of light 1 only makes it difficult for the user to grasp and locate the object in the virtual environment. Whereas for the second condition, F-light but no light 1, shows that the use of F-light alone causes the user to grasp effectively, but it is difficult to move and locate the object. Meanwhile, the last condition, F-light with light 1, shows the combination of F-light and light 1 shows the user can grasp, move, and locate the object effectively. So this finding demonstrates that obtaining the intended impact critically depends on the illumination direction. Shadows and illumination may give design features like viewpoint, depth, dimension, realistic art, and visual fascination. Display illumination can draw attention to particular features, improve the overall visual attractiveness of object, and establish the ideal ambience. Indeed, the depth-dependent attenuation of light greatly enhance the impression of depth perception and dimension. Besides, the inclusion of the shadow depth cues in this study provide evidence to suggest that incorporating a visual cue during interaction could enhance control efficiency. In addition to improving visibility, the shadow depth cue also significantly contributes to the effective control of virtual objects. Initially, the researcher believed that illumination could potentially address this issue because it is closely associated with shadow, which are also visual cues. However, research findings signify that using the appropriate illumination model can achieve more than just improving shadow casting. With the correct illumination model, objects in the virtual environment can have the right dimension and be purposefully illuminated to produce effective or aesthetically pleasing effects and high-quality images. Nevertheless, these enhancements are reliant upon the quantity, position, and intensity or luminance of light sources. In a nutshell, the precise placement match the equation integrating F-light and light 1 and the framework diagram demonstrate how an ideal illumination model could improve the renderer pipeline on the screen and effectively control the interaction of touchless hand gestures like grasping and manipulating functions in the virtual environment. That's all about the research. Thank you so much for listening.
Hello and good day. My name is Ng Seng Beng from the Faculty of Computer Science and Information Technology, University Putra Malaysia, Malaysia. I'm here to present you the title Enhancing Machine Vision Pose Measurement with LiDAR and Stereo Camera Integration through Artificial Intelligence. As for the contents, I will cover first of all introduction and background, then LiDAR pose measurement, visual pose measurement, deep learning measurement methods, problems in existing research, and finally the conclusion. LiDAR, or its full name is called Light Detection and Ranging, is an active optical remote sensing technology that requires relevant target information by capturing scattered light in the target. LiDAR provides precise pose information by transmitting and receiving light pulses and measuring the distance of objects. Through the integration of LiDAR and stereo camera, as well as the application of AI algorithms, the accuracy and reliability of machine vision pose measurement can be significantly improved. AI, especially deep learning, has an important impact on the processing and analysis of 3D point clouds, which can process and enhance the fusion data of LiDAR and stereo cameras to achieve more accurate pose estimation. Future research will focus on solving the challenges of real-time data processing and improving the efficiency of the algorithm, further enhancing the accuracy and application scope of machine vision pose measurement. In today's rapid developing scientific and technological environment, accurate body posture estimation has become a core requirement for many applications, especially in the frontier technology fields of automatic driving, robotics, and augmented reality. Traditionally, body posture measurement techniques do not perform well in diverse environmental conditions and complex tasks, which limits their effectiveness and accuracy in practical applications. Artificial intelligence or AI, especially deep learning, has shown significant advantages in analyzing and processing data from LiDAR and stereo cameras, indicating its great potential in the field of post-measurement. LiDAR determines the distance of the object by transmitting and receiving the reflected light pulse and calculating the time of flight of the light so as to measure the pose of the object. Because of its high precision and strong adaptability, LiDAR has been widely used in post-measurement in aerospace, navigation, meteorological monitoring, and military fields. Despite the many advantages of LiDAR post-measurement technology, challenges such as real-time data processing and improving the efficiency of the algorithm still exist, and further research and innovation are needed. The advantages of LiDAR include high measurement accuracy, good monochromaticity, strong directionality, good coherence, small size, and relatively higher temporal and spatial resolution. There are 4 different laser ranging methods. First, direct laser ranging. Second, polarization modulated laser ranging. Third, continuous wave modulated laser ranging. And fourth, pseudo-random code laser ranging. The table shows the comparison between flash ranging, polarization modulation ranging, continuous wave ranging, pseudo-random code ranging in terms of range of action, measuring distance accuracy, range resolution, scanning LiDAR, and planar array LiDAR. This table shows the comparison of stereoscopic vision measurement and also monocular vision measurement. Basically, stereoscopic has the advantage of it provides richer spatial information and precise 3D reconstruction capabilities, can directly obtain depth information of objects. Nevertheless, the disadvantage will be high system requirement and computational costs, high demands for camera calibration and synchronization. On the other hand, monocular is low-cost, simple system, easy to deploy, suitable for applications with low equipment requirements. But it lacks depth information. Scene understanding depends on the complexity and accuracy of algorithms, may be affected by lighting and motion blur. Stereoscopic vision sensor methods. Figure A shows the binocular vision measurement process of depth map recovery. B shows point cloud alignment, and C shows the positional solution. This table shows the 3 different types of depth cameras. First of all, structured light. Second, TOF stands for time of flight cameras. And also lastly, the stereo vision. Okay, the main examples of these 3 types respectively are Microsoft Kinect for structured light, time of flight is Microsoft Kinect version 2, and also stereo vision will be the Intel RealSense D435i DJI. This table shows some methods in single view deep learning methods, mainly on voxel-based methods, mesh-based methods, point cloud-based methods, 2D supervised methods, and implicit function-based methods. Meanwhile, this table shows multi-view deep learning methods based on voxel, mesh, point cloud, and also 2D supervised methods. Artificial intelligence role in LiDAR and stereo camera integration. AI algorithms can process and optimize a large amount of data to improve the accuracy of post-measurement. The importance of deep learning in AI integration. Deep learning technology enables AI to process and interpret data more accurately by learning and understanding complex patterns. Influence of AI integration on machine vision post-measurement. Machine vision post-measurement, more accurate and reliable, brings new possibility for the fields of automatic driving, robotics, and augmented reality. There are few problems in existing research. In single view, there are limited or restricted visual cues, and also occluded views, and also there's a challenge in accurate shape measurement. Meanwhile, in multi-view, there is a lack of adequate exploration of inter-regional correspondence between different views, resulting in inaccurate feature merging and unreliable measurements. Methods typically capture only one type of feature, either global or local, for shape generation, limiting detailed visual information and complex shape measurement. Moreover, the semantic connections between views are underexplored, and while RNNs are used for learning these connections, they risk losing earlier views feature due to long-term memory decay. Conclusion. Through the integration of LiDAR and stereo camera combined and with AI algorithm, the accuracy and reliability of machine vision post-measurement can be significantly improved. AI, especially deep learning, has an important impact on the process and analysis of 3D point clouds, which can process and enhance the fusion data of LiDAR and stereo cameras to achieve more accurate post-estimation. Although there are challenges such as real-time data processing and algorithm efficiency, future research can overcome these challenges through innovative solutions and advances in sensor technology. This paper examines the evolution in multi-view 3D post-estimation, transitioning from geometry-based methods to advanced deep learning techniques, driven by improvements in computer hardware and the availability of large 3D shape datasets. Voxel representation can be used for simplifying 3D reconstruction from 2D images and addresses the challenges of achieving high-resolution outputs, which are crucial for detailed shape accuracy. Alternative methods like point cloud and mesh representations can offer more precise geometric details, illustrating their significance in applications such as robotics and autonomous vehicle to enhance safety and efficiency. These are the references while compiling this review paper. That's the end of my presentation. Thank you.
Assalamualaikum and a very good day to everyone. My name is Normalia Samian. I'm from University Putra Malaysia, representing my team to present our project on innovating traceability in the food supply chain management by using Internet of Things and blockchain technology. So this will be the outline for my presentation, starting with introduction, problem statement, research objectives, and so forth. For introduction, we will talk about food security in general and how we could achieve it. So to achieve food security, there are several angles that we can look into, such as the food quality, the sufficiency, and food supply chain has become one of the crucial goals in achieving food security. Okay. When we talk about food industry, they actually face many challenges that dampening the targeted goals, whereby food supply chains have become more complex with diversified sources of productions, especially from farms or agriculture sectors, such that monitoring and authenticating the product quality is becoming more and more difficult. So there is a need, having this kind of situation, there is a need to create a digital transformation of the food supply chain, where in this situation or in this project, we are suggesting the integration of Internet of Things and blockchain technology to assist in achieving this goal. Okay, let's talk about the Internet of Things in general first. Okay, so the Internet of Things or IoT has emerged to be a revolutionary technology that is transforming the way people interact with the world. Okay, an IoT system in agriculture lets farmers monitor and optimize soil moisture, temperature, and nutrient levels, and it allows stakeholders see the location, condition and handling of agricultural goods, reducing losses, waste and supply chain efficiency. So IoT uh, commonly will target about how to make a particular system become automated. Okay, especially in agriculture sectors, the automation is needed so that the whole production or the whole process will become even more smooth, right? So, for example, IoT can help farmers schedule irrigation and improve crop protection, right? This can actually decrease the crop losses, increase the supplies, and improves food security for local and global market. Let's talk a bit about blockchain technology. For your information, this work is the subsequent version from our previous one. So we won't talk about blockchain, the fundamental of blockchain technology much. But if you wish to find out about the blockchain and also detail about our previous work, you may find the information on the published journal that I've shared the information down there. Okay. So the food industry plays a vital role in ensuring the safety, quality, and openness of the products consumed by people around the globe. However, the traditional or conventional systems lack traceability and the possibility of fraud. So blockchain technology has emerged as a potentially transformative way to provide visibility and traceability in the food supply chain, okay, whereby blockchain technology could monitor food quality and safety by digitally tracking data and process of material resources with the help of the IoT. Okay, let's moving on to the problem statement. Right. What happened today is that many existing farmer sector lack informedness in transferring and sharing data along the food supply chain due to relying on a distributed database system. And also the system itself is highly decentralized and distributed where each system has their own authorization such that the sharing of information may not be possible, or if there is some sort of information sharing, the uh, the duration of sharing is kind of long and causing delay, right? Such that prompt information will not be able to be obtained. So conventional food supply chains are managed using manual documentation, isolated monitoring processes, and autonomous system, as I said just now, resulting in inefficiency of communication among stakeholders along the chain and delays in responding to any changes or fluctuations. Right? And the whole process of food supply chains lacks transparency and traceability, making it difficult to track the movement of food products and identify potential issues of inefficiencies that can hinder hinder the goal to ensure food safety and quality. So for our research objectives, we aim to develop an IoT system that can provide automation for monitoring the quality of food production and integrate into local database systems with cloud storage so that data can be fed into blockchain smart contract and create easy access among stakeholders along the supply chain. Secondly, we aim to develop a blockchain-based system for the food supply chains by using smart contracts and consensus algorithm to provide stakeholders along the chain with extensive details regarding the products and to ensure that no single entity has control over the data, fostering transparency, accountability, and trust among stakeholders. This could actually provide consumers with accurate information about the flow of the food product from production to consumption. because blockchain, its nature is distributed and decentralized, where every nodes in this blockchain network could see what every other node is doing. So this part of our literature review, where the one that I presented here is the one that we focus on the existing system on IoT system for food quality monitoring. So the similar system that we have found is such as the TELSPEC, all right, SCIO, and also NEMA partners. And all of these IoT system does not have blockchain implementation yet, meaning that they get the data, they obtain the data for certain particular monitoring purposes, but they don't use that data to be fed into a blockchain system such that the whatever that happens in their system could be also monitored and accessed by other stakeholders, because that's the function of blockchain. If it's being shared with any data by the joint stakeholders, or the joint nodes, or what we call it as joining nodes, right? So they will be able to see what happened in a particular section, okay, or in a particular block that, for example, this one, the IoT system could be uh, included in one of the blocks that provide information about uh, food quality monitoring. Okay, and this one is the literature review on some of the blockchain implementation for supply chain. So we look into the logistic parts and also some of the agriculture and food. Okay, so they definitely employ smart contracts, okay, between the stakeholders, right? And the main goals for this blockchain implementation for supply chain is that so that they are able to assess their product all the time, and also reduce the time to track product origin. Okay. So food supply chain is a big industry. Okay, so it could cover the agricultural products, fisheries, and so forth. Okay, so the one that we take as a case study for our project is on the poultry industry. So we aim actually to provide end-to-end visibility using the blockchain technology, starting from the farm to the dining table. Right, so whereby customers could actually see the whole journey of the chicken, okay, right from the farm right to the retailers, okay. And definitely smart contract plays important roles along the supply chain. Okay, so this is the system design for our IoT system. We actually providing a prototype, and we focusing on detecting temperature and humidity level of a chicken that is being transported from the factory, okay, to the retailers. Okay, so in this project, we actually just providing or developing a prototype. So this is the design of our blockchain system, where we implement a consensus algorithm, right, that become the backbone of the smart contract that must be agreed by all the stakeholders along the supply chain. So this is the overall design of the integration of IoT and blockchain system. So as you can see here, we have a prototype here using Arduino and Raspberry Pi. Only that, sorry, that the food that is being captured here is the apple, which represent chicken in real life. Okay, so we have this IoT temperature and humidity sensor to provide automation, where we pump into the IoT system on a cloud base. Here we use the Amazon cloud account, okay, and then the data that is pumped into the cloud storage will later be grabbed by the blockchain server, okay, or the blockchain network. Okay. Here, the blockchain system in itself involves several important elements like the back-end development, where we have the smart contract, and also the Web3 or the D apps for the blockchain. We use MetaMask, right? And we have the what we call the front-end application development. Okay, so that all the processes or can be viewed by each stakeholders that involved along the supply chain. Okay, so this is the what we call the input from the sensor of the IoT system that will be transferred into the blockchain system. Okay, so this is our blockchain system where it has been the smart contract has been translated into the front end system, okay, on the Web3 application, where you can see here. Okay, one of the important input is from the IoT system. Okay, so the input fed that you saw just now, okay, has been fed into this blockchain system such that the accurate temperature and humidity level of the chicken, okay, can be viewed by all the stakeholders or entities along the supply chain. Okay. Other than that, we also have the food status, like this slaughter status and also halal status. So every stakeholders will play their own particular function or task, specific task. So in this case, if let's say we go to the halal verification part, okay, so the halal verifier staff will get to access the current status of the poultry. Okay, so they need to provide information like answering question like does all raw materials used are halal compliant, right? Does the labeling and packaging of the products meet the halal standards and so forth. So if all of this can be ticked, it means that the what you call the slaughterhouse, for example, has been actually following the policy that has been set and agreed by all the stakeholders along the supply chain. So let's say if one of the uh, requirements cannot be ticked, that means that the slaughterhouse does not fulfill one of the conditions that has been set. Then later on, there will be, as you can see in the red font here, there will be error notification stating that, for example, your item is non-halal. So when that happen, all the stakeholders along the supply chain will get to see that, and that means that the slaughterhouse has been violating the contract that has been agreed beforehand. For that matters, such information will also be able to be viewed by end user or by consumers, which are us. All right. So this is the what is actually being tried to be achieved by our blockchain system, okay, integrated with the IoT system. Okay, so this is the one that I mentioned just now, where we are actually getting the prompt and accurate evaluation provided by the legal stakeholders. Okay, so here, the slaughter status, for example, your item is not fully slaughtered correctly, right? And halal status, your item is non-halal. So when this happen, people will be informed immediately when they check on the status, so they won't actually they can take their own precaution and do proper action, okay, for their own benefits. All right, so that's a bit about our work lah. For conclusion, the integration of IT system and blockchain technology brings about a new era of automation, transparency, accountability, and efficiency in the food supply chain, right? Whereby this empowers stakeholders to make well-informed decisions, reduce risk, and optimize operation. Okay. So given the ongoing changes in technology and consumer preferences, this research provides valuable guidance for using decentralization to build a sustainable, fair, and robust food ecosystem in the evolving field of food supply chain management. As future work, we want to develop a mobile application because we need the part where consumers can scan the QR code of particular chicken products, and they will be able to see where that chicken comes from and has it been verified halal, has it been slaughtered properly, and who actually do that, and so forth. Okay, so this mobile application utilize a traceability system and make sure consumers can report and make informed decisions by providing accurate and accessible information about the journey of the food, including sourcing, production, and handling process. So that's it from me. Okay, so these are our references. Thank you very much. Terima kasih for your attention.
Hello, my name is Jostimata Tarigan, and today I'm going to present one of my recent research with my college, Muhammad Shah Fikri and Fauzan Nur Ahmadi, and the research titled Emotion-Based Behavior for Non-Playable Character in Game. We are from the Faculty of Computer Science and Information Technology, Universitas Sumatera Utara. So what is an NPC? Non-playable character, usually we call it NPC, is a character in game that does not controlled by a player, usually interact with player's character. The intention is to add some kind of immersiveness between the player and its environment. The interaction defines by a behavior system, method to define and organize action and decision based on NPC. There are several methods that can be used to define a behavior system. One of the most common is probably finite state machine, which is probably one of the mostly used method to define a behavior system. There are also other methods such as behavior trees and rule-based system, and rule-based system is probably the simplest one and the easiest to understand and implement. Our objective here is to introduce behavior system for the enemy NPC. So it's a kind of NPC that the purpose is to challenge the player with the intention to add difficulty to the game. This is an example of behavior system. So the rectangular shape defines the state of the NPC. There are 4 states: patrol, chasing player, attacking player, and retreating. Each of these states define the action that the NPC will take. So the patrol, the action is move around the perimeter. Retreating, the action is move away from the player, etc. Switching from one state to another is triggered by the condition of its environment. So for example, while during the patrol and the NPC detects the player, then it switch the states from the patrol to chasing player. When during the chasing player, the NPC detects that the player is in attack range, then it switch the states from chasing player to attacking player. Now, however, the common issue of NPC is very predictable. It can be very predictable. It's not challenging because it's players. Because if a player is able to predict the NPC next movement, then the purpose of making the game harder is a bit hard. However, if we add the complexity of the behavior system, it can diminish the playability of the game and it become not enjoyable because it can be very hard for the players to predict the NPC. So we must balance between the difficulty and the playability. The common solution is to inject intuitive behavior, is to implement intuitive behavior. Basically what it means is we add the complexity but based on something intuitive that the player able to understand with minimal learning to trial and error. Developing this behavior system give additional challenge, but it keeps it intuitive for the player, so it's easy to understand. So the player easy to understand and easy to predict what kind of behavior the NPC will have based on its intuitive. So we introduced the emotion-based NPC's behavior. Actually, this method is commonly used in previous research. The idea is to add complexity without making it look complex. The solution is rely into intuitive competence. There are several research that argue and already prove that adding intuitive component can increase the complexity of behavior without diminishing the playability. And one of the most commonly used intuitive component is emotion. What is emotion? Emotion is how we feel, how human currently feel, and it's easy for us to predict what is our action based on the emotion, because we already feel that in real life. We already able to access the emotion of someone emotions and predict their action based on this emotion. So it's easy for players to recognize their expression and to can encounter based on his experience. There are previous research that shows the involvement of emotion in NPC interaction increase playability, and some of this research, actually most of this research, able to create a very complex NPC, very complex behavior system while maintaining the playability, because player able to predict what kind of action the NPC will hold based on his current emotion. So we propose two layers of behavior system. The first one is emotion-based layer using a fuzzy inference system, and the second one action layer using finite state machine. Emotion affect the behavior based on the internal composition of the NPC. For example, if the NPC have a good health or the aggressiveness of the NPC. The action affect the behavior based on the external condition. For example, the interaction with the player. It changes the state of the NPC by determining whether the player is in psych or not, for example, like that. We call it emotion-based agent in our system. EBA is the NPC that utilizes emotion as part of the decision making. This is the overall architecture of our system. So the left part is the emotion layer driven by fuzzy inference system, and the triggers is player attacks, HP depleted, etc. And then the output of this emotion layer is the current state of emotion of the player, of the NPC, and based on this emotion, the NPC will define the action that triggered by the sensor and the current emotion. This is the example of a fuzzy inference system of the anger emotion. So yeah, I forgot to tell you earlier that there are 4 states of emotion: calm, anger, fear, and determination. And the anger, fear, and determination has 2 values each, and we define these values by using a fuzzy inference system. For example, the anger emotion has a calm or low, annoyed medium, and furious high. And we define this anger using a fuzzy rules, and it actually the one that triggered the anger is the current health of the NPC. If the enemy has low health, then the anger is high, which is predictable, easy to predict. If the enemy feels threatened, he become more furious, trying to survive with it by using most of his power. But if the enemy has high health, then he felt less threatened, then the anger is low. So by using this kind of emotion, we develop this a bit more complex behavior system that has an additional states. So the yellow state is a classic FSM state that only affected by the player, but by the player that trigger the changing state. And the greenish one is the cyan or greenish, I don't know. It's the one that also defined by, not only defined by the player that triggers the changing of state, but also by the current emotion. So for example, there are 2 kind of state: flee and aggressive attack. To test our proposed method, we built a very simple game that simulates our proposed method. It's a third-person shooter built using Unity, and the objective of the player is to kill the NPC. And as you can see, the NPC in this current state is still in patrol mode, where it will walk through a perimeter and trying to find the player. And this is the example of interaction I don't think I can capture it's hard to capture the video. So I put the image instead, because the most interesting part that I want to show is there's an emotion icon in the left part of the health bar. This icon is to make the player understand what is the current state of the emotion of the NPC. And by using this icon, the player can predict what kind of action will the NPC holds. So there are three kind of emotion that's shown here. The first one is calm, because the health is full and it currently does not attack the player. The second one is furious. It feels threatened because its health bar is low, but also the player is also shows a very weak health bar. And the third one is terrified, because the NPC has a low health bar and the player seems to be healthy, so the NPC will be frightened by the players. Now, we also perform the usability test to figure out whether our proposed system is good or not, and does it increase the playability of our game. We collect samples from 31 testers. We use a Likert scale-based question followed by a short interview to evaluate their understanding of method. We split the question into 4 categories: overall gameplay, interaction with enemy, understanding the effect of emotional AI, and comparison with non-AVA. This is the result of our test, and in short, most of the testers agree that the ABA shows a very positive addition to the gameplay. However, while the proposed method has a good addition added a good value to the game itself is still lack of complexity, so it's hard for them to judge whether the emotion-based agent actually give a significant playability value to the game. However, based on our interview with the tester, they are all able to understand the behavior of the NPC, judging by the current emotion of the NPC, and they are also able to recognize the emotion by looking at the icon on the left health bar, and they mostly use those icons to predict what kind of behavior.
Assalamualaikum warahmatullahi taala wabarakatuh, and good day everyone. I am technologist Dr. Rahani Muhammad from Intelligent Computing Research Group, Department of Computer Science, Faculty of Computer Science and Information Technology UPM. Will be presenting and enhancing smart home security with Hawk algorithm for International Symposium on Intelligence and Internet of Things in perspective from Indonesia and Malaysia. So this is the table of contents that comprises of introduction, related work, methodology, system design, limitation and future recommendation, as well as conclusion. As introduction, shelter is a basic human need crucial for survival in case of natural hazards and human-induced disaster, including conflict. So it provides security, personal safety and protection from the weather and prevents health problems and diseases. So the question arises here, how effectively are our house protected against potential intruders who may seek to enter our residences? The typical solution for addressing this concern is by investing in home security system. However, the important consideration here is the system to protect the house itself. Therefore, the study is focused on providing solutions with more improvement over the existing system. So I enclose here with is the incident happened in Klang on March last year. So basically what happened is an armed robbers burst in on family in Klang. So we didn't want this thing happen, and we want the residents that encounter with this kind of emergency will get help constantly. So the constraint and gets from the current home security system is noted as number 1, conventional lock system is lack of modern security features such as camera, numpad, and also LCD. And also the conventional lock system require constantly manual monitoring. So this study proposed on number 1, design and implementation of smart home security system with the current technology and AI embedded. And number 1, the smart security also function with video camera, control lock system, and also has the ability to detect any burglary activities. The related works that has been studied before we propose this project is based on the previous work in this table. Okay, some of it have no features of ultrasonic. Maybe some of the work didn't have features of face recognition, and maybe didn't have any LCD ability or features for the system, and also didn't have the solenoid lock. So in our case, in this proposed project, so we propose all the features combined together in one system with the ability to have the face recognition with the AI embedded with Hawk algorithm, installed with ultrasonic, keypad LCD solenoid lock, and also has the ability to notify the users, and the platform used is using the mobile apps. So the methodology of this project is using the life cycle of embedded system development. It has 5 main stages. Number 1 here is planning and analysis. Number 2, design. So meaning here is comprises the design flow chart, the sketch UI and UX for smart home apps, and also design the layout of the location where the sensor can be installed and placed at home. And the implementation using the coding and also flowchart, and etc. And number 4 here is testing. Run all the sensors and smart home application to be connected to the system database and ensure that all the coding are free from syntax and logic error, also runtime error. And the last phases is deployment. So this is the system architecture of the project. It comprises 3 main category or main subsystem inside. That is, first is burglary detection system, door lock system, and also face recognition here. And this is the system design with all the flowchart that comprises all the features that has been talked before. Alright, in terms of face recognition, we use the Hawk algorithm and DLEAP model. We use the Python library face recognition, which utilizes the Hawk algorithm and DLEAP for face detection. Hawk here, derived from histogram of oriented gradient, is primarily employed for face and image detection. It measures the gradient intensity of each photo for detection. The DLEAP here includes a facial cascade for human face detection. RGB images are converted to grayscale and downscale to reduce processing time. DLEAP also locates faces in the photo, uses the Hawk algorithm to convert them to gradient images and calculates pixel intensity in the region. Pixel density of each face is utilized for facial recognition and store the model file that is called a pickle. So in terms of implementation, we install the sensor in the front door on the top and also the backside chicken window. ESP32 also has been installed in every region, for example, for the door lock, for the burglary detection, and also for monitoring and face recognition. We also have the real-time database, whereby this database stores all the important information for the system to work correctly, such as state, passcode, token, and also IP addresses. And this is the UI for smart door lock apps, right? This is the door lock system, and then this is to update the door passcode. And this is for the UI face recognition. So user's face will be captured by using front camera. Up to 20 pictures will be taken. User enter a desired name to be registered into the system. And for the burglary detection, so this is the UI for burglary detection in the apps and the logs of the burglary detection. So user can enable and disable the sensor. The log is collected every time the sensor is triggered. So this is how the logs has been captured in the real-time database. So the user also will get the notification from the burglary detection. So when the sensor is being triggered, the ESP32 will send the notification to smartphone and record it in Firebase. So other than that, there is other apps features that has been installed or designed in the apps. Okay, the first one is manage the current user, add new user, and also for door monitoring. There is limitation and future recommendation for this project. So two limitation has been listed here: low resources and also face recognition. Low resources here is meaning due to hardware limitation and ESP32 controlling the door via the mobile apps may experience delays of up to 5 seconds due to other concurrent processes. So number 2 is regarding the face recognition. Due to using only facial recognition with a camera and not 3D scanning technology, there's a chance that twins could unlock the system even if not registered. So there is two also recommendation listed here. Number 1, improve the centralized server architecture. So optimize the use of ESP32 software to minimize mobile app door control delays. Consider central server task offloading. And number 2, enhance face recognition with 3D scanning to detect unauthorized access, especially for identical twins. So that's all for this presentation. Thank you very much. And have a nice day, everyone.
Hello everyone, a very warm welcome to each and every one of you who watched this video. Let's kick off today's presentation by diving into the world of deep learning topic with Mrs. Dr. Amalia and Mrs. Sri Melvani and me Hajarin Satwana with title Hyperparameter Optimization of DenseNet 121 for Beta Thalassemia Major Detection on Android. We might be curious about what is thalassemia. Thalassemia it is the inherited blood disorder indicated by the condition where the production of beta globin chains of hemoglobin is either reduced or absent. It is seen most frequently in people of Mediterranean region, the Middle East, Central Asia, India, and the Southeast Asia. How about beta thalassemia major in Indonesia? According to data from the Indonesian Thalassemia Foundation, there has been a continuous increases in thalassemia cases. Since 2012, there were 4,896 cases reported, and by June 2021, the number of thalassemia patients in Indonesia had risen to 10,973 cases. In thalassemia, we know the term of Golgi face, or we call it mouse face, or mongoloid or rodent face, are characteristical facial features used to describe thalassemia patient. The frontal and parietal bones become prominent. The zygomatic bones protrude. The nasal bridge on the concave and may widen. The eyes exhibit a mongoloid slant. There is a notable hypertrophy of the upper maxilla. What we can do to achieve a broad accessibility, portability, user-friendly, and real-time processing, we build the system on Android. And we have to get accurate face recognition. So for accurate face recognition, we need the best model, the best architecture. So in deep learning, we know the terms of hyperparameter. In hyperparameter, we optimize the hyperparameter so we get the best model with highest accuracy. Like I said before, we use two hyperparameters. First, base size. Base size refers to the number of training examples utilized in one iteration. For example, if I have a 96 training example and I choose a base size of 32, it means the model will be trained on 32 examples at a time. This process is repeated until all examples in the dataset have been used for training, which completes one epoch. In learning rate is a hyperparameter that determines the size of the steps taken during the optimized process. If the steps taken are too big, you can reach the optimum point. If the steps taken are too small, expensive costs will be incurred and the process will take a long time. Okay, next I have architecture of DevNet 121 that you see on the table. Here we have convolutional pooling, dense block, and transaction layer. And the end we have classification layer with 7 by 7 global average pool, and finally 1000 deeply connected with softmax. Here, how do you get the optimal value? We use random search. This is a random search method. As you can see that the most optimal area will be found. And this is our flowchart of optimization in start, and then we type content, set batch size, and learning rate, and accuracy and loss obtained. And then read random batch size and learning rate, and then train the model, push accuracy and loss at a time according to the hyperparameter set, and then ask, random selection complete? If not, back to B process. If yes, go to A. In A, find the maximum accuracy and minimum loss. Go to the question, is maximum accuracy more than 90? If yes, obtain the optimal hyperparameter and then finish the process. If no, back to the B step. In image classification, we always hear image augmentation. Here, I use augmentation with parameter rescale, rotation with shift, height shift, shear, zoom, horizontal flip, and fill mode. This is general diagram of the system. User will input image data on Android. In Android, processing on the model, and model give inference or prediction, and in Android will show the prediction output to the user. In trial training, I get 14 trial with combination from batch size and learning rate. The best model that I can get is in validation accuracy 93% with accuracy 97% and loss 0.1 and fall loss 0.2. It is in 5 trial, which batch size 8 and learning rate 0.001. Okay, let me show you our application in Android that we have with here. And the first, our name application is thalassemia detection. You can choose in camera and then get your photo. After that, click OK, and then this is result healthy face with analysis result 99% healthy. And you can use from gallery. This is from gallery for healthy face. How about if there is thalassemia people? Here I have photo thalassemia people, and the result is thalassemia classified, and you can see the analysis result. Okay. Optimization comparison. So here I comparison between optimized hyperparameter and default hyperparameter. In optimization hyperparameter, batch size 8 and batch size in default is 32. In accuracy optimization, 97% and default is 94%. In validation accuracy, optimized is 93% and in default is 90%. Loss in optimization 0.1 in default 0.18. Validation loss in optimization 0.24 and in default hyperparameter 0.26. Yeah, and this is the loss function that you can see. The loss in that we optimize is 0.1 and in default 0.2, which is the best is in optimized model. This is the test result that I get health people and thalassemia. In example picture 2, there is thalassemia people that you can see the accuracy in thalassemia 99%. And here the result. In X picture, it's my patient that have thalassemia, and the presentation of thalassemia is 99%. So the conclusion, by optimizing using random search for 14 trial, the best combination of batch size and learning rate was obtained. Namely, batch size X and learning rate 0.001 provide high accuracy reaching 97% with validation accuracy reaching 93%. For loss, it is 10% and validation loss is 24%. Okay, this is my explanation about our research, and thank you everyone.
Hi, Assalamualaikum. I'm Dr. Nur Alifah binti Roslan from Faculty of Computer Science and Information Technology, University Putra Malaysia, Malaysia. So I will presenting my research title, Enhancing Secure QR Code Steganography Through Artificial Intelligence. In this presentation, I will cover the introduction, related work, methodology, conclusion, and future work. QR code or quick response codes are frequently employed in our daily life. Mobile devices can read the data contained from the QR code and transmit it to the public. However, they are crucial in terms of security issues. This study presents a method for achieving product authentication through data concealing. The strategy involves using user data to generate a quick response code or QR code, which is then embedded into the product logo picture. The embedded QR code is not visible to the human eye. The aim of this research is to employ the CNN method to conceal a QR code within the logo picture of the user's product. Let's go for the related work. CNN, or a very powerful neural network that can be classified as a regularized version of multi-layer perception, or MLP. The following is the advantages of CNN. CNN extracts features of the images automatically. CNN effectively uses the adjunct pixels information to effectively downsample the image first by convolutional and then uses the prediction layer at the end. CNN performs well and gives better accuracy. Through this literature review, we find out that CNN can enhance the security of our QR code steganography. Therefore, by employing a deep neural network, namely a convolutional neural network or CNN, individuals may get a comprehensive understanding of the interact patterns present in the real photograph. The network will possess the capability to discern which region is superfluous, allowing for the concealment of more pixels in that certain area. The secret picture is embedded into the carrier image in a manner that ensures the resulting stego image closely resembles the original carrier image. Our research employs a CNN architecture to conceal a QR code picture within a carrier image. We are creating a QR code that contains information about the product or ownership, such as business registration number and product production ID. We are then inserting the QR code picture into the user's product logo image. The objective of this system is to achieve the data concealment using cryptography and steganography. Specifically, the ownership data of the product will be concealed by generating a QR code and then hiding it using steganography, ensuring the presence of the QR code remains unknown. There are two parts of our methodology. The first part is the objective of our suggested system is to implement steganographic technique to conceal a QR image, including user product ownership data within a user product's logo, which is a carrier image, in a way that renders the QR imperceptible to the human eye. The system will primarily comprise a QR code generator that generates a QR code picture containing user information. The CNN network will primarily consist of the three sections, which is a preparation network, a concealing network, and the reveal network. The combination of this network will create a complete system for both encoding and decoding the image. This is the proposed interface of QR code ownership generator, where we have the product ID or ownership of for the ownership serial number of the business. Okay, and then we will embed all these both information to generate a QR code. Here is the proposed architecture of the CNN model, where we have the user product ownership information, and then we generate a QR code using the QR code generator that I presented previously in the previous slide. And we use the user product logo image as the carrier image, and we train the CNN model. And then we will retrieve the QR code embedded image in order to in order to retrieve back the QR code embedded image, we will put or insert it into the decoder network to retrieve back the QR code image. By scanning the QR code, the restored QR code image, we will get back the or retrieve back the user's insert information. This is the proposed training model, where we will get the training dataset from the tiny image net dataset, which consists of 2000 images of dimension 64 times 64 times 3. And then there are two phases. The first phase, the dataset is processed using the Keras image library and the Adam optimizer. The feature of the secret image are extracted in the prep network of the encoder CNN. Then the cover image and the output of the prep network are processed as input in the hidden network of the encoder CNN. We get a container image that will contain the embedded secret image into the cover image, such that the container image will be visually similar to the cover image. From the second phase, we give the outputted container image as input to the decoder CNN and restore the secret image from it. The encoder and decoder CNN are trained simultaneously during training, and the weight are updated simultaneously. After the model training is completed, we will use this model for embedding QR codes into our color images, which is the user's product logo. As conclusion, our proposed model provides an adequate data hiding mechanism for protecting the sensitive data. Here we are achieving data security by generating a QR code consisting of the user product ownership information, and then we will embed the generated QR into the user product's logo image such that very existence for the QR will be invisible. The CNN are utilized to implement the steganographic method. The system has two CNNs, namely the encoder and decoder, which are responsible for embedding and decoding the QR code respectively. The suggested system has the potential to enhance the data security and effectively mitigate the risk of data breach. Essentially, the encryption method may be substituted with more advanced encryption methods, while the techniques for securing the secret picture is reliable. Employing cryptographic algorithm like Advanced Encryption Standard (AES) or Data Encryption Standard (DES) is outside of the scope of study. This is before this algorithm encounter a challenge in retrieving an encrypted picture as a result of the use of lossy neural networks. If lossy neural networks are successfully developed in the future, we will have the capability to incorporate them into our system using contemporary cryptographic methods. Exploring the future potential of developing cryptographic algorithm compatible with neural network is a very promising area of study, which will include in our future works. That's all for my presentation. Thank you.
I am Bahyaki Siregar, representing other research members from Universitas Sumatera Utara, requesting permission to present our paper entitled Robot Arm Control Using Electromyography Signals Read from Human Arms Movement. Robot is one of the technologies that have been used to replace and relieve jobs that require manual equipment and human labor. Robotic arms are widely used in industry, especially in industries that require precision work and work repeatedly. Researchers have developed a variety of techniques for controlling robot arms, including employing sound, electromyography, EMG, or electroencephalography, or EEG. The most widely used robotic arm control is using EMG signals. EMG captures the activity of muscle contraction. The signal's amplitude changes can be processed to detect movement, but doing so needs sophisticated processing, including pattern recognition, which is often required to identify hand movement. In this research, EMG signals reading will be carried out and then classified, which will be used for move the robotic arm through the wireless network, which aims to make it easier operation of a robotic arm that is used remotely on jobs with different conditions cannot be done by humans directly. The method developed from this research is employed by the Mayo armband, a gadget that can pick up EMG signal from the muscle of the arm. A EMG muscle sensor of the highest quality and an IMU make up the gesture controller known as the Mayo armband. When a human arm is attached to the Mayo armband, it detects impulse from the arm's muscle and then calculates the arm's orientation using information from sensors including a gyroscope, accelerometer, and magnetometer. Its servomotor on the arm robot utilized in this study can rotate the waist, shoulders, elbows, wrists, and grippers. The arm robot used in this study has 5 degrees of freedom. This general architecture demonstrates the system's 3 steps, which are the sensing stage, the computing stage, and the actuating stage. The user's arm is attached to the Mayo armband at the sensing stage in order to interpret muscle movement as an EMG signal and transfer it to the computing stage for further processing via Bluetooth. The Mayo Connect software examines the EMG data collected during the sensing stage to identify the pattern of the user's palm gesture and arm direction. Pinch, fist, open, wave in, and wave out, which are basic Mayo armband motion, were used in this experiment. Next, the EMG signal and pattern are read and analyzed by the Node.js application utilizing the Mayo.js package using the API. The next robot arm in the actuation stage may use the algorithm to examine and decide what choice to make. A raw data capture of the EMG signal is also produced by application for use in more sophisticated analysis. After the connection of my connect was successfully established using the script that the researcher made and initialization to this connection was also successful, the pose of the human hand attached to the armband device began to be recognized as one of fist, finger spread, wave in, and wave out. For the fist pose, the data is set as PG0. For the finger spread pose, the data is set as PR0. For the wave in pose, the data is set as PD0. And for the wave out post, the data is set as PU and 0. Furthermore, the data obtained is sent to an Arduino microcontroller via a serial communication line. If at this stage the post is not detected, the system will take values from the orientation on the x-axis and z-axis to move the lower part of the robot arm. The next step is to arrange data transmission to the Arduino microcontroller, which functions as the controller of the robot arm. After the initialization process on serial communication and servo is successful, and the robot arm is in the normal point position, 90.90, then the microcontroller waits for serial data to enter it. When it is found that there is incoming data, then the data is parsed. If the first data is P, the second data will be checked whether in the form of G, R, D, or U, which will have an impact on the next movement, namely whether the robot arm will apply grip the finger, take off the grip, lower brace, or raise conditions brace. However, if what is found in the first data is M, then the next data will be checked whether the next data is an arm per arm movement or an arm inch movement. The test was carried out by moving the human arms as the respondent of this research. The movement performed on the forearm are by raising the arm, lowering the arm, swinging the arm to the left, and swinging the arm to the right. While on the palm side, testing is done to open the palm, grip, wave in, wave out, and pinch. After several tests involving several respondents, the results are shown in this table. The real-time status means that the robot arms moves very smoothly, following the direction of the movement of the human arm. The responsive status means that the robotic arm moves in the direction of the human arm, but with a slight delay. The condition sometimes fail means that there are numerous occasions when noise prevents the robot arm from reading the EMG data. Some visualization evidence when testing has been carried out for palm movement can be seen in this figure, namely this palm open, wave out, and wave in movements. The conclusion are the user's arm movement, such as raising or lowering it or swinging it to the left or right, can trigger a real-time response from the robot arm. The robot arm can detect the user's arm muscle and occasionally react to input by generating an EMG signal. However, there are occasions when the robot arm won't. When the test is repeated multiple times due to noise in the EMG signal, the system is unable to make decisions using the algorithm's range of input values of user arm fatigue, alter the way the read EMG signal is processed. Thank you very much.
Good morning, everyone. I'll be presenting on the topic utilizing fine-tuning ResNet-18 for acute leukemia diagnosis from blood smear images. This research was conducted by me, Triandi Sinaga, under the guidance of our first advisor, Dr. Eng Adichandra, STMCom, and our second advisor, BD Purnama, PhD. In our medical research, we focus on leukemia, a cancer affecting blood and bone marrow. Acute leukemia requires quick diagnosis for effective treatment. Our study shows resnet-actin potential in image recognition is underutilized in acute leukemia diagnosis, indicating a need for further research. We choose resnet-actin for its strong feature extraction and pre-trained knowledge from datasets like ImageNet. Its architecture allows for detailed feature learning and fine-tuning to specific tests. Transfer learning is essential in our approach, adapting resnet-actin for various applications, including acute leukemia diagnosis, despite dataset constraint. Leukemia is a cancer that affects the bone marrow and blood, especially white blood cells. It is divided into acute and chronic form. Our research analysis shows that resnet-actin has potential in image recognition. However, its application for diagnosing acute leukemia is still limited. This is an important research gap that serves as the basis for our study, thus requiring further investigation into the potential of resnet-actin in diagnosing acute leukemia. Here are several pertinent studies from the foundation of my research. In this slide, we are discussing resnet-actin, a neural network model known for its ability to recognize image effectively. It works through four main stages. First, it builds on existing knowledge from large dataset like ImageNet. Then it learns specific feature from the input data essential for accurate image classification. ResNet-18 is flexible, allowing its layers to be adjusted for new text, and it can apply its learning insight to different but related text. The architecture diagram illustrates the network layers, showing connection between wake layers via value activation function representing how network transform and learn. Our research problem revolves around the extent to which fine-tuning resnet-actin can enhance the accuracy of acute leukemia diagnosis, serving as the primary focus of our research. Our goal is to use resnet-actin fine-tuning to improve acute leukemia diagnosis accuracy from blood smear images. This research contributes to advancing medical diagnostic. In our methodology, comprises 5 key steps: selecting resnet-actin architecture, known for image recognition, using annotated blood smear images dataset for training, preprocessing data for improved performance, fine-tuning the model for acute leukemia diagnosis, and evaluating its accuracy and effectiveness. In this session, we'll explore our research framework. It begins with data collection and cleaning for integrity. Then, the data processing includes partitioning and augmentation. The core is developing the deep learning model with fine-tuning resnet-actin, validated and evaluated. We analyze results and conclude with finding and future direction. We'll explore resnet-actin, known for its efficiency in image recognition. ResNet-18 employs shortcut connection and convolutional layers to learn the architecture effectively. This is our proposed method. This is our proposed architecture, modifying the fully connected layer of ResNet 18 by adding linear layer and output layer, followed by ReLU activation, and final classification layer with softmax activation. This enhances feature extraction and improves classification performance. Our dataset is compiled from two sources. The first from RSUP Haji Adam Malik Hospital, and the second, all IDB from the University of Milan. Blood images were collected and meticulously prepared at RSUP Haji Adam Malik Medan, following medical standard. High quality image were captured using an Olympus DP 72 camera with precise techniques. Analyze ensure image quality and validity in accordance with research ethics. Each image was extensively documented, including patient information, before being organized into a dataset for further research. This is the image, depict the data collection process at the hospital. And this is the following image illustrates the step of capturing images using the CD 72 digital microscope camera. The data collection process for the all IDB dataset entails submitting a sample requires from form to the University of Milan, which then provides the relevant soft copy data in response. The dataset table shows leukemia and normal classes from dataset RS and all IDB, including 509 leukemia and 517 normal sample from dataset RS, and 49 leukemia and 58 normal samples from OIDB. In total, there are 1,133 samples in dataset. Here are examples of leukemia and normal image sample from dataset RS. And this is our example, and here are example of leukemia and normal images samples from IDB1. For pre-processing includes data cleaning to ensure the integrity, and data distribution for training and testing. Augmentation techniques are then applied to enhance the dataset for improved model performance. Data cleaning involves identifying and removing inappropriate image, ensuring lighting and focus consistency, and further inspection to eliminate noise image. We combine dataset RS with OIDB1 and divide the dataset into three subsets: training, validation, and testing. 80% for training, 10% for validation, and 10% for testing, while randomizing the data order to prevent bias. The slide illustrate the distribution of classes across training, validation, and testing subset. Here are the augmentation process. Augmentation includes resizing image and applying random rotation and horizontal and vertical flip, color adjustment, and random cropping, and normalize using ImageNet dataset statistic for enhanced training stability. Fine-tuning ResNet 18 involves adding two linear layers with ReLU activation, using dropout to prevent overfitting, and optimizing with Adam. FX learning rate of 0.0001 and weak DC of 0.00001 are applied for consistency and regularization. Softmax activation function is used for clear prediction interpretation. To assess the effectiveness of detecting acute leukemia in blood smear images, we use the following evaluation metrics: accuracy, precision, recall F1 score, specificity, and AUC rows. This is the result from our research. ResNet-18, fine-tuning ResNet-18 consistently improves performance, reaching a peak validation accuracy of 99.12% in just 9 minutes and 15 seconds of training. This enhances the model accuracy in identifying images. This is the graph training and validation result. The graph illustrates a trend of increasing accuracy and decreasing loss during training. This indicates that the model consistently learn from the training data and improve in making accurate prediction. Evaluation metrics. The model achieve high high accuracy, namely 99.12% and perfect recall 100%, indicating its exceptional performance in correctly classifying instances. In this slide, we present the evaluation metrics for our leukemia identification model from blood smear images, showcasing high accuracy and perfect performance demonstrated by the confusion matrix and receiver operating characteristic curve. This slide emphasizes the performance imbalance with fine-tuning ResNet-18 outperforming VGG16 and MobileNet V2 in accuracy and stability. It underscores the significance of fine-tuning for improving model quality and reliability. In this slide, we present the evaluation metrics for our leukemia identification model from blood smear images. Here in this slide, this show all classification 5 cross validation performed. The result of the 5 cross validation indicate consistently high performance for fine-tuning ResNet-18 and MobileNet V2, while VGG 16 exhibit lower performance. Conclusion in this slide, in summary, our study achieved 99.12% accuracy on birth validation and test dataset, with superior performance in precision, recall F1 score, and AUC rows. Fine-tuned ResNet 18 outperform other models like VGG16 and MobileNet V2, demonstrating stable improvement in diagnostic acute leukemia. This highlights the effectiveness of fine-tuning ResNet 18 for enhancing medical diagnosis. For future research, in future research, we aim to explore additional augmentation method for enhancing ResNet 18's performance and assess the feasibility of fine-tuning MobileNet V2 for leukemia classification. Additionally, we plan to utilize ensemble learning with ResNet 18, PGG16, and MobileNet V2 for improved prediction stability. Thank you for joining our presentation. We hope the information shared has been helpful. Special thanks to all who supported this research. Let's continue collaborating for a future solution. Thank you.
Hello everyone, I'm Irfan Akbari Habibi, and here I will present a research entitled detection of non-halal food ingredients based on machine learning and cloud computing, which was conducted by Srimal Fani Hardi, Irfan Akbari Habibi, and Ivan Jaya from Faculty of Computer Science and Information Technology, Universitas Sumatera Utara, Medan, Indonesia. Okay, the background of this research consists of three main points. First, the majority of Indonesia's population is Muslim. According the Royal Islamic Strategic Studies Center or MOMDA, there are 237 million Muslim in Indonesia, and data from Badan Pusat Statistik Indonesia 2023 also show that 87.2% of the total population of Indonesia is Muslim. The second is many Muslim tourists abroad, according data from Badan Pusat Statistik 2022. And third or the last is halal food is a Muslim obligation based on Afrihanti. Say halal food and beverage are those that are permitted for consumption according to Islam. The rules for Muslim consumption of food and beverage are clearly and firmly laid out in the Quran, Surah Al-Baqarah. Next, this is the main problem of this research. The first is the difficulties ordinary people face in determining the halal status of products stems from the limited halal information available on packaged food and beverage that lack halal labels. And the second, a composition detection system for the halal status of packaged food and beverage product is needed that supports multilingual use to cater to tourists in diverse non-Muslim majority countries. Next, this is the scope or limitation of the research we conduct are as follows. First, using LSTM or long short-term memory and using Google Cloud Platform. Number three, ingredients dataset obtained from USDA, Food Data Central, and Open Food Facts. Number four, the number of supported language follow the Google Cloud Translation documentation. Number five, information on non-halal food ingredients is taken from halaladi.is.its.ac.id, cogc.org, and lahorecomsats.edu.pk. And next, the amount of text and characters that can be recognized follows the Google Cloud Vision documentation. And last, using Google Cloud Platform as filter. Next, the goals of our research. First, empowering Muslim and Muslim tourists, enhancing awareness of halal food and beverage products, and then leveraging machine learning and cloud computing innovation, and multi-language customization, enabling multilingual support within the application. This is the problem analysis. It is difficult for ordinary people to know the halal status of packaged food products due to limited halal information on packaged food or drink products without halal labels, especially for imported products and Muslims who are traveling to other countries. This is LSTM that we use in our research. LSTM is part of recurrent neural networks with advanced memory capabilities that are very suitable for handling long short-term dependency. LSTM is designed with the aim of extracting hidden layers in each memory cell and retaining of information from previous memory cells. The general architectural form of LSTM consists of a memory cell, input gate, output gate, and forget gate. There are several previous research in the same topic. The first is from UNIRT, design of integrated latex halal detection text using OCR. And number two from Widya, aplikasi barcode scanner food halal pada produk makanan impor bahasa Android. Number three from Bangkit, implementasi names entity relay recognition and optical character recognition, bentuk aplikasi pendeteksi kehalalan bahan makanan. And number 4, from Taranum, halal food identification from product ingredients using machine learning. This is an original architecture that we use in our research. And this is cloud architecture that we use. We use Google Cloud Platform as a cloud computing service. And this is a raw dataset. There are 2 columns, text and label, and the text is food ingredients that we get from some source, and this is the label for the ingredients. And you can see in this slide dataset class distribution for halal category and haram category. This is the LSTM layer. We use layer embedding, to LSTM layer, to dropout layer, and to dense layer. And after training LSTM, you can see this is a training result per epoch from epoch 0 until epoch 22. And the red font indicates that there's no increase of validation accuracy from this training. This is model training grade training and validation accuracy. You can see in this slide, and this is training and validation loss from model training. And this is the screenshot from mobile application that we built from Flutter. This is login page. This is home page. Next, this is a scan page that shows camera page, and this is the result page. The first is raw pictures, and below is composition and ingredients that extracted from this picture and the result of these ingredients. This is a favorite page. Conclusion of our research is LSTM algorithm can be used to predict composition text for packaged food and beverage products by recognizing patterns or context in the composition text. Number 2, with cloud computing, the development and deployment process is easier and more efficient. Number 3, the number of layers, activation function, text length, and number of epoch greatly influence the complexity of the models. Number 4, the accuracy of LSTM model is greatly influenced by the number of variety of dataset used during the model training process. Number 5, the model's accuracy in predicting composition during training was 99.82%, and the accuracy using real sample testing data was 84%. The final result of the system can be a reference for Muslim in knowing the halal status of the composition of food and beverage products, especially imported products. I think that's all from my presentation. Thank you, everyone.
Okay, Assalamualaikum. Good day. I'm Associate Professor Dr. Masnida Hussein from University Putra Malaysia. I'm presenting my research work on the awareness in data share activities on digital platform, prioritizing data attribute using Bayesian network learning and Bayesian classifier. All right. What we mean by the public data? We mean by the personal information such as names, phone numbers, email addresses, home addresses, also our health data related. The sharing activities in digital platform can be considered as a broad spectrum of information, openly and with a larger audience. This leads to increased risk of data leakage due to the free exchange of personal information. Also, the perception of privacy among the public vary and leading to different levels of awareness and understanding. Okay, in this research objective, where we aim to categorize the data attributes from data that commonly and publicly shared, and also to raise awareness by providing data privacy catalog to a knowledge public. Okay, some background studies that we classify into several groups, which is we are focusing on first, we are focusing on existing work on the data privacy, and also we study on how the privacy been classified, and then how the Bayesian network classifier able to categorize or category all the data. So from that, we start our research by using this methodology, 5 steps, which is data observation collection, and then we form a classifier, find analysis, public verification, and catalog implementation. So you can see in public verification, we have two steps. After one to another, they will go to find analysis back, because we did 2 phase of verification process. Okay, this is a 15 data attributes that we get from various resources. Okay, these are listed over here. Alright, so then we form a survey from to get the input from the respondent, which is from diverse social circles. We get the 200 participants to represent the public, where they are responsible to determine which data attribute that fall into which levels. That here we have a low, medium, and high privacy levels. Okay, this okay, then from the survey, the first round survey, we got this kind of sorting of the data attributes according to their privacy level. Okay, this is numbers of respondents that they think these data attributes either in low class, medium class, or high privacy class. Okay, from that input from the first step survey, we then bring the numbers, bring the input back to the lab. We classify it using the Bayesian classifier. Okay, so this is how we calculate and how our algorithm or how our classification engine works using the Bayesian classifier. Okay, this is how we derive the Bayesian value to determine the level of each data attribute. Alright, this analysis, okay, after we complete the lab-based classification using Bayesian classifier, we then again we'll analyze the rank of the data attributes, and we compare what we gain from the Bayesian classifier process compare with the initial input from our respondent. So we compare that two collection of data, collection of the list of the data attribute in this phase. Then we get this output, okay, with the initial ranking, and then after we form it in the lab base, which is using classification, then we have this rank for the data attributes. So then we go back, give back our final, which is final Okay, after we compare the first initial rank of the data attributes from the respondent, and after we get back and after we do the classification using Bayesian classifier, we compare that two output, then we give back to our respondent to get their either they agree or not with our latest list of rank of our data attributes. So this is the output from the respondent, the same respondent that from initial collection of the survey. So most of them agree with our latest ranking of the data attributes. Some of them, in fact, we can see it's more than 50% of them agree on the rank, how we sorted the ranking of data attribute. So okay. Okay, then we form the catalog. It's actually the product for this research. Okay, based on the most recent privacy rating produced by two-step verification process, the data attributes catalog is created. This catalog aims to raise public awareness about the privacy of their information and their right to keep it privately. Alright, as conclusion, by building the comprehensive data model, there is a goal to increase public awareness through the classification of privacy levels of public data elements. By utilizing the naive Bayesian classifier, public data attributes can categorize into low, medium, and high privacy classes. This initiative aims to underscore the importance of privacy in public data, thereby prompting the individuals to exercise caution when disclosing the information, particularly on open digital platforms. It is imperative to discover data privacy policies to ensure the utility of available electronic and digital mediums while safeguarding public rights. So these are all the references that we refer from existing research. Okay, with that, I thank you.